Seconds. Hello.
I know, all emails matter. I've done it before, I'll do it again.
13 seconds. All right, I guess we can start then. Hi everyone. So this is Stephen Gallagher's talk, but he's not here, so I'm sorry, it's going to be me. My name is Adam, and I work at Red Hat as product owner for a bunch of teams working on like the internal RHEL pipeline, which includes also emerging RHEL and CentOS Stream. And if you saw any of my talks like in the previous years, this is what I would be talking about, the CentOS Stream. That's where RHEL development happens in public. This is sort of the flow overall, like how changes are introduced, where everything starts in Fedora, of course, like all the innovation happens there, and then it slowly transitions and lands in RHEL. You could kind of like draw these two bubbles around it, and there's different goals with each bubble. Fedora development is like, the goal is to build a community distro for everyone to use, while on the other side we have CentOS Stream and RHEL, which is an enterprise product. And that's what I would normally focus on, but we're gonna look at the blue stuff today. So this is kind of the key to all of this, Fedora ELN. This is the logo, and because I had to steal at least one slide, so this is a slide from a talk that Troy Dawson and Stephen Gallagher gave like 2 years ago at Flock. And this is what Fedora ELN is. So it says that ELN is a build root and a compose process for Fedora that takes Fedora rawhide sources and emulates the RHEL build and compose. And it allows us to explore new ideas like higher CPU baselines and other things that will not disrupt the rest of Fedora. We had this since RHEL 8 Bootstrap, so that's like 6 years, 9 years, I can't count. But we're doing 11 today. So this is the same stuff, but it's more like a visual representation. You can see that the sources for the Fedora are one thing, for CentOS is the other thing, and then Fedora ELN, CentOS Stream RHEL, they have like a very specific subset of packages, and also the build flags are different. So why am I talking about this? This is how the code sings, and the thing between Fedora and ELN is happening all the time. CentOS is happening all the time, but there's this bootstrap thing. This is the branching. This happens like every 3 years. And I think you want to know when that happens and what that means. So this is like a visual representation of the same thing. You see that we did 10 from like Fedora 40, and we'll be doing CS11 and RHEL 11 from Fedora 46, which brings me to a small correction. So this is the original title for the talk. It says that RHEL 11 is branching from Fedora 46, but I had to do a little bit of a change there, and this is a 2 month difference, and I think that's quite important to realize. What do I mean by this? So this is from the Fedora release schedule. And you can see a few days, there's the mass rebuild, then there's a branch, beta freeze, final freeze for both releases. And what matters for us, for ELN and for RHEL 10, is actually these. So you have mass rebuild 45, mass rebuild 46, and please come back, yes. And the branch, and that's the same event as the branching. We don't wait for the beta freeze or the final freeze. So if I show you the same thing on like a picture, you can see, right now we're basically at the beginning of the slide, like at the very edge. And in about a month, we'll have the first mass rebuild. So everything will start appearing in CentOS Stream. And we will go Fedora 45 branches. We have the end of the year. And then in January, like all the work begins. So if you want to get something into RHEL 11, please, please, please do it as soon as possible. Ideally, if you put it into Fedora 45, that's your last chance to be able to test it in a Fedora release. So if you want to test it in Fedora, please put it into Fedora 45. If you really need to wait for Fedora 46, please do it by the end of the year. We don't have the whole cycle. And even though the branching is in January, that'll be very busy because the team will be cutting GCC, mass rebuild, branch, and off we go. I was also asked to put this slide on. Please don't do that. Don't ask me why I had to have this. But yeah, this was super short. I wanted to had time for questions. So these are the dates. 45, 46, and please don't forget that the branching and the final release, the final freeze, that's 2 months. So the branching, that's what matters, but end of the year is the best. Yeah, that's the whole talk. Thank you. Right, any questions? Yep.
Why do you branch off so early and not wait for the beta or final freeze?
The thing is that the development is set up, the Fedora ELN development setup is always tracking Fedora Rawhide. And we don't want to do like a branch to Fedora 46 and then suddenly come back to Rawhide. So basically when Fedora 46 branches, Rawhide starts tracking RHEL 12. And that's where we branch RHEL 11 as well. So it's like, it makes more sense that way. It doesn't matter, you can't get changes in after. Like in the end, you can get changes into RHEL 9 right now if you talk to the maintainer and like engage the right people. But the easiest is to do it before the branching, and then like it's more work and more work, but yeah.
So this will be the only branching or importing from Fedora, because I don't know which version was whether it was 9 or 10, but there were like 2 events. One was branching, and then before beta there was another mass import from Fedora. So it's not happening for RHEL 11.
Yeah, I don't think we will be doing that. Some maintainers might choose to like still be pulling changes, but the mass sync will be turned off with the branching.
Not a question, but just more statement. When I was doing the rebase of protobuf in Fedora, which, if you don't know about it, it was a 6-year delayed rebased, complicated one. I was curious how many packages are in a similar state that they were not rebased despite being new version in upstream. And I discovered that not alone, we have many of such, and that's not record one. There's one package that was not rebased for 10 years, despite new version in upstream. So this may be another push for like, can we rebase such packages as well? So I may ask, and I'm not asking alone. Like, so I've wrote some help utilities and scripts that may help you to find this and help with the rebase. So I wanted to make it announcement before Flog, but it will probably land next week. So yeah, we may start trying to push on the rebases a little bit more than previous releases.
So you, RHEL would like changes by the end of the year. What changes would RHEL like to see Fedora drop on December 31st, 11:59 UTC?
I would say that's up to Fedora. I don't think RHEL will be telling Fedora what to land. That's the purpose of Fedora. So whatever lands, that goes. I think what would RHEL like to see is not like maybe a specific thing, but the way you land it. Like, please make Fedora 46 or like before the year as polished as you can. So there's not like, if you want to do some big revolution, maybe do it in 45 or 47. But that way you have some leeway in case things go as they sometimes go. So I think that's the only ask I have. But otherwise, it's up to Fedora what you choose to land into Fedora. You,
I'm trying to decide what to ask in public, that's all.
yeah.
There are cases where RHEL does not look like Fedora, and where CentOS does not look like Fedora, and that's engineering choices that Red Hat makes. Btrfs is the obvious one. We always use an example. Are there cases? Are there things that like Red Hat has on its drawing board that it would be nicer to have those things land in Fedora? Not that Fedora has to do them, but like it would help a whole lot with the testing and the entire SDLC if we get those things into Fedora earlier. Like, are the DNF changes a big thing? Do we need to be ironing those out?
That's a good question. I also want to say I'm not the right person to answer this.
That's right.
Yeah. Sorry. I'm an infrastructure guy, so I don't tell people what to put into the packages. I try to stay neutral in that way. Yeah.
What do you want in RHEL 11? Not RHEL. What do you want in Fedora for RHEL 11? You, Adam.
Me, Adam.
Yes.
Easy to build packages.
Huh?
Easy to build packages?
Yes, packages that build easy and that don't cause disruptions
Okay, things
in the
that are possible in
infrastructure.
life.
I quite like the DNF5. So one thing I worked on was Content Resolver, which is like a tooling that basically figures out what to pull into Fedora ELN from Fedora Rawhide. So like from those 27 or whatever thousand packages, like the 2,200 what we have. And we have someone who's working on porting it to DNF5. And they're not done yet. They're not done with optimizing. And it's almost 3 times faster already. So thanks for the DNF team. I'm quite happy with that. Yeah.
Yeah, I wanted to answer the previous question a bit. I made in the Node.js in Fedora and also in RHEL. So yeah, there are some changes we want to land in Fedora before branching RHEL 11. If you use Node.js in Fedora, you might notice that we recently tried to make the streams more parallelly available and switchable between streams, and there are one more change that is scheduled to land soon, hopefully. And yeah, we consider the branch for RHEL 11 as a hard deadline that we want this to have happened. So the RHEL 11 would have Node.js with these features. So
Very cool.
Not speaking for the entire Red Hat or RHEL project, but at least some changes we want to have in Fedora before that.
Maybe it matters less what I want, but like if there's something you like, this is a great time to talk to Fedora maintainers and get the conversation going and like get it landed. Yeah, we were asking a question.
I have the mic.
Yeah. Oh,
I just
sorry.
wanted to say that the person who was going to come to Flock, Brian Stinson, who could have answered that question really well, is not here. But we have product owners, and Brian Stinson leads them. You know him. He's shown up many times at Flock and DevConf and CentOS Connect. And each of the product owners has their own goals. So we heard about Node.js, what they want to see land in these next releases, and so they're the people who will work to make that happen, essentially.
I want to apologize. I came a little bit late, so if this was answered, just boo at me, and I'll ask you later. But you said, "Dear Fedora people, please do something in time for something." Are you also saying, "Dear RHEL people, do the stuff in Fedora before it branches"? Are you having that kind of conversation internally, and how can Fedora RHEL people like me who are both help make the default, because I have this feeling that there are people who are Fedora people as well as RHEL people, and they understand it, and those are the people that usually come to places like this. And then there are RHEL people who have very little knowledge how this all works. You would probably not meet them here, and then we drop something on them, and suddenly they will be asking the difficult questions in 2 years, like, we are already doing RHEL 11 and stuff like that. So how can we make it so that the changes for RHEL 11 or 12 or whatever are actually done in Fedora in time, so that how can we motivate people, and it's a hard question, so I don't expect you to have the actual answer, like more like a brainstorming, to actually start working on RHEL 12 features in Fedora today, or maybe in a couple months, instead of in 3 years?
No, that's a good question, and that was part of the reason why the emerging RHEL team set up Fedora ELN, so we can keep doing that continuously. Like, when I think RHEL 8 was the last one that we didn't have ELN for. I can't remember, but like it was an entire year of like a lot of work of like taking Fedora and like trying to rebuild it and like whatever. Now ELN is doing it continuously. So what we can do is, I think there's already some messaging internally that please look at ELN. When people are adding new packages to like existing even RHEL 9 or 10, like we ask them to also add it to ELN so we can see it for 11 and 12 in the future. And yeah, like right now, as like this talk happens here, you will see some reminders popping up on RHEL Devel, which is like the internal development mailing list, and maybe your product owners will start talking like with the teams about this. But yeah, as Steph said, like we have these new like concept of product owners. So I think through them, that would be a good way to make sure that like things are prioritized well. And yeah, like it's important to like separate the RHEL business and Fedora community. Like I haven't tried to say people to like, hey, you have to do this because RHEL is branching. That's not this venue. Like it's more like if you're interested, you can. If you're not, that's fine. Yeah. I hope that answered your question at least a little bit. At least a little bit. Okay, cool.
Oh, hi. Question from the chat. Will there be a rebase for x86 64 Arch, EL9 enforced v2, EL10 enforced v3? What about EL11?
Oh, that's a good question. Yeah, I forgot to mention that. So x86 and AR64 will remain the same baseline as they are now. So what's in Fedora, what's in RHEL 10, that will remain. PowerPC will be bumping to 10, and Z6 and like S390 to Z16. And I think in ELN the team wants to switch to Z16 in like a month-ish, but PowerPC will be switching in like later this year. Still not know exactly where. But yeah, we want to wait for CentOS Stream to get a PowerPC 10 builder, and that will happen in like maybe later October-ish, I don't know, something like that. Yep.
Hiya.
Hey.
So can I flip the question? Instead of what you would like to see, what are the major changes expected between RHEL 10 and 11? Like off the top of your head, what can you see as the most major feature changes?
I'm really the wrong person to ask. I had like my head down in the infrastructure. I'm trying. Yeah, I wish we had Brian Stinson in here, or like any of the PMs. There was a talk from Scott McCarthy in FOSDEM, or like CentOS Connect. He gave like some sort of overview of like the way the product will be like delivered. The features, yeah, I can't tell you off the top of my head. Like I'm the absolutely wrong person to ask. Sorry.
I have a question.
Yeah.
From the milestones that are presented here, I see the 45, the Fedora 45 is where, you know, when you do the mass rebuild, and it's like the Fedora release where things can get tested.
Mm-hmm.
And then 46 is like a parallel development to the RHEL 11, right? How should be the handshake, like in case of the mass rebuild happens and there will be some testing after, how does that feedback loop happens between the RHEL and Fedora?
So In terms of package ownership, after the mass rebuild, there's the branching, and since the branching happens, then RHEL 11 is like owned by RHEL maintainers. So Fedora maintainers don't need to be necessarily concerned about RHEL because that's what we have people to take care of. Of course, there's relationships. Sometimes it's the same person. So if you're the same person and you feel like you want to pull changes, that's totally fine. Like you can keep doing that for months and months, right? But we want to be clear that if the maintainer is different and maybe like the RHEL maintainer has a specific approach and the Fedora maintainer is a volunteer, like don't rely on the volunteer too much to like do work for you for RHEL at that point. But like, so yeah, that's where the ownership branch is.
So I think in a way I'm asking if that January 20th is like the cutoff for the RHEL 11 and then it's mostly testing. Is that how it is?
It will be, yeah, there might be testing, there might be integration. I will be working on composes, images, and stuff like this. What's maybe worth to point out that by that date, we want to have like the package set sort of stable. But if some things don't work necessarily, maybe like the ISO doesn't boot and stuff like this, that's fine. That's the sort of work that will be happening after. But that will be like considered RHEL work already. It'll be happening in CentOS Stream, like you will be able to see, test everything that's happening there, but it won't be no longer on you. Yeah.
Thank you. Any other questions? We have a few more minutes.
There's one.
I was curious how you guys think about changes that might not land in these specific windows. Like there was a couple of really good post-quantum cryptography talks. And, you know, those timelines keep creeping forward in ways that so much of it's in flux and it can't make it into this window, but I'm sure RHEL 11 will have to care about it at some point.
Yep.
How do you guys think about those kinds of problems? Not just for like that specific example, but these things that you don't have out of your, you guys have out of your control in RHEL, Fedora has out of their control, but the larger tech space still needs them integrated into these OSs.
Yeah, if you look at like RHEL 10 or even RHEL 9 or CentOS Stream, CentOS 9, where the development happens, there's still new features pulled in, but they like there's just a little bit more scrutiny, right? Like at that point, you can't make, we don't want to make changes that break your ABI. Each change is like considered more thoroughly. But it doesn't matter that, it doesn't mean that it's impossible. So yeah, if there's some new crypto that RHEL wants, of course it gets pulled in. But it's not automatic. Like for the Fedora community, like before the date, if you land it in Fedora, it gets to RHEL automatically. After that, it's a conversation. But yeah.
A good example was OpenSSL.
Oh, that was.
RHEL had a fixed schedule, and we knew that we needed to support for a long period of time. I think it was RHEL 9 at the time, right? And the challenge was that the OpenSSL community kept pushing back their release, but the RHEL release was fixed, and so we ended up in this really weird place, which was awkward, and I'm sure everyone can think of ways that it could have been handled better, where we had to land a new version of OpenSSL in RHEL and in Fedora roughly at the same time, rather than first bringing it into Fedora, letting it stabilize there, and then going to RHEL. So those kind of annoying things happened for exactly the reason that you're describing.
Any more last questions? Okay, I'll bring it. Travel time, sorry.
Do you plan to like semi-automatically backport patches from Fedora 46 into RHEL 11? Because I mean, I'm a bit concerned about the timing of the branching, like the Fedora 46 is going to be stabilizing at the same time with RHEL 11, and it seems like we are going to duplicate the stabilization efforts.
If you're asking me, the answer is no. If you ask the RHEL maintainers, maybe. Like it's still the same dist-git format, so like it's a question of like you push to Fedora and maybe you push to the RHEL dist-git as well. CentOS Stream dist-git. So like if you're the maintainer, it's up to you. You can do that, but like the emerging RHEL team who's like orchestrating all this, there will be there's no planned automatic sync for these. Although you probably be able to ask. We haven't discussed this, but I can see a reason, like if you're a maintainer and you say, hey, I have these 3 packages, I still want to keep them in sync, can you please keep doing that? Maybe we can have that conversation. Like that would be technically possible, and I don't see a reason why we couldn't do that. If you take care of like the build failures, if they happen and stuff. So maybe, yeah, maybe we can make that happen. That's a good idea. But that's not something we thought about, but yeah.
Okay, we are on time. Thank
All
you,
right.
Adam.
Thank you.
So, so yeah, there's actually a mic here as well. So, this is the State of the Fedora kernel talk. I haven't given this talk in a couple of years, and a lot's changed actually in a couple of years. It's for a long time the Fedora kernel was maintained in a particular way, and that was fine, and it was great. But we've moved to kernel arc several years ago. It's probably been, what, 6 years ago now? And so as we moved to kernel arc, a lot of things changed about how we maintain the kernel, how you might possibly test a patch, how you might maintain your own kernel. And that's why I'm here now. So kernel arc is the supposedly the always ready kernel. That's what arc stands for. It is merged in with Rawhide on a daily basis, or merged in with Linus's tree on a daily basis. Today is running a little bit late for my fault. I'll get to that later. But it does try to actually merge in daily. We build daily, or at least 5 days a week. Sometimes I don't build on weekends. And then from that, we have, there was a repository quite a while ago called the no debug kernel, because we built Rawhide kernels as debug kernels. We don't build them as debug kernels anymore for a lot of reasons dealing with performance that just made them unmanageable, right? We lost the benefit of doing so. But I do still keep the Rawhide debug kernel repository up to date with a once a week RC snapshot. It exists, but yeah, it's not really no debug versus debug anymore. It's just for the people who only want to update once a week. Now, for stable Fedora releases, we follow Greg's tree. We follow Greg's tree religiously. I will build on weekends. I will build whenever it happens. So that is always managed upstream. The way that we actually do these things, and so the QR code here is actually linked to the kernel arc repository, and so OS build is our master branch where we merge in Liz branch and all of those things. We also have a branch called Fedora-7.0 right now. There's whatever the current version is that we're building to stable, that's the branch that we maintain for stable releases. So, like, actually, as of yesterday, 7.1 was released. Last night, I guess. Time zones are weird. But sometime this week, I will create a Fedora-7.1 release branch. And that branch will have not all of the patches that are in Rawhide. It will have some of them, and that will be what we actually ship to Fedora stable releases. And so the reason that it only has some of them is because there are some branches or some patches we carry in the Rawhide release that are really rel specific, and the policy on those is all of those patches have to actually do like if defined. They have an if-def on a config rel release. And if they have that, which rel defines and Fedora doesn't, then they'll follow that code path. We don't follow that code path, so technically those patches are no ops for Fedora anyway, but they're there for rel, and that's great that they're there for rel. My problem is I have a whole lot of bugs. I've got, 500 and some odd bugs on any given Fedora release at any given time. And so part of the way of dealing with those bugs is saying, can you please deal with upstream directly? It works well, a lot of times anyway. But when I ask you to deal with upstream directly, and if they ask you to apply to a patch, and that patch doesn't apply because of some patch that we have that's a, diff, that's problematic. So I try to get rid of all of those patches, as many of those patches as I can. Fedora is as close to upstream as we can possibly be. Now, realistically, we still carry 60 some odd patches. Things like Secure Boot. Finally got upstream after 7 years, but what got upstream as kernel lockdown does not actually automatically turn itself on if you have Secure Boot enabled in your EFI. So we still have to carry the patches that do that part of it. Lockdown is enabled, not enabled if you're just due to EFI settings. And so we carry those things to make those things happen correctly. Strangely enough, I think every distribution is now carrying our patches to do the exact same thing. For years, every distribution was carrying our patches to actually enable Secure Boot at all because we were the only ones doing it. But it's there. So these are we do have deviations from upstream, but we try to keep them as minimal as possible. So one of the things that I will be turning on with 7.1, which I have not turned on with previous kernels, is there are some deviances for FIPS mode. Some things that upstream will not take, but that Red Hat feels are important for FIPS mode. And there are things like external hardware random generator, things like that.
What's FIPS mode?
FIPS mode is a US, as far as I know, it's just a US, but it is a federal, so there's a certification process, and Fedora will never be FIPS certified because from my understanding, FIPS certification takes a couple of years. Well, yes, and a lot of money. And then there's the flip side of it is, but there are things that FIPS has said, there are cryptographic things that FIPS has said are acceptable and are not. And so when you enable FIPS in the kernel, and it's a boot flag, kernel boot flag, FIPS =1, that will turn all of that on. You disable a bunch of cryptographic stuff that is not considered acceptable, and you only go into what is considered acceptable. Like I said, Fedora has RHEL has a couple of things that we did not carry in Fedora because upstream wasn't carrying them, and I didn't find them critical. Until you find out that there are actually users, even though we're not certified, we can be FIPS compliant. And so we found out we had a couple of national labs users that were trying to boot Fedora in FIPS mode, and it wasn't working correctly. So we'll be adding those patches into 7.1 and should be more FIPS compliant, even if it's not certified. And it never will be because the lifecycle of Fedora is shorter than the certification process. No, it really is. I think it's something like 2 years to get certified.
It's almost 30 months usually.
Yeah.
It's pretty long.
Right. So, yeah, the life cycle of Fedora at all is never that. So, like I said, we do try to stay as close to upstream as possible, but we are different from upstream in a few ways. And so, how are we different from upstream? When we build things out of kernel.ark, it is a source git branch. If you're used to most Fedora processes, we have dist-git, we have this tarball plus patches and spec file or whatever. We do that for kernel, but we don't actually look at it. We don't manage the kernel in that way. We manage it in a source git branch. And that source git branch is the exploded kernel tree. It's great. You can look at it. You can do all of these things with it. You can maintain your own branch if you'd like to, and you can do it in a way that's very easy to merge with what we're doing from a dist-git standpoint. But we don't look at dist-git. And when I say we don't look at dist-git, if you are a proven packager, technically you can contribute to everything, right? If you make a commit to dist-git, it's actually automatically overwritten by anything we do. When I do make dist-git, I'm not even looking at it. Well, technically I do because I don't want to step on anyone's toes necessarily, but realistically, it just overwrites everything automatically. And so when I do the commit, I look at the diff, and if somebody's done something, then maybe I'll reach out to them and try to make sure that we're in sync. And the other thing we've done is we've turned off pull request for dist-git at all. Do everything through the kernel arc branch. So if you want to see how we differ from upstream, there's actually 2 ways. Because the Fedora policy should say that, all right, well, we carry all of our patches, and here's the upstream tarball. And when we build, we do actually still have the upstream tarball that is built, and then we have one patch that is kind of everything. And that's not great at telling you exactly what we're carrying and why. So we do have a patchlist.changelog, which has every patch we're carrying listed out. It'll have the SHA, so you can actually check it out, but kind of give you an idea of what we're carrying, why we're carrying it, right? Ideally, but the idea is Fedora is as close to possible as upstream, and part of why we are is because right now Fedora is me from a kernel standpoint, and so from trying to get things fixed, you file a bug. I'd like to help you out a lot of times, but there's a whole lot of bugs. And really, if you can go upstream and deal with upstream directly, that's great. And if they can send you a patch, you can do all of that. So what we have here, if you need to build your own kernel, and this is why that kind of all ties in, there's actually a file. There's a patch included in the spec file called Linux kernel test patch. It's a 0, there's nothing in it. The whole purpose of that is if upstream tells you, hey, try this patch and see if it fixes your problem, you can actually copy your patch to this and it will automatically be applied. You don't have to change the spec, you don't have to understand the spec at all. And suddenly your patch is applied, you can build it, you can test it, and see what you think. For single fixes, well, even if it's multiple patches, you can put as many patches in there as you want, but it's a single patch file that applies. If you're trying to test something upstream, that's a very quick way to do it without having to deal with Git, without having to deal with really anything. Now, if you want to maintain your own branch, someone like Asahi and what they're doing, you can actually just branch what we're doing. And there's a wonderful thing called makefile.variables. What makefile.variables does is it allows us to separate our branches and say, all right, well, here's our upstream. So when I do like Fedora 7.1, which I'll do this week, I say our upstream is Linux 7.1.y, which is Greg's upstream tree that I'm pushing, right? But if you want to do your own branch that's based on Fedora, you can say, all right, well, my upstream is Fedora 7.0 or 7.1. And you can then manage your branch all you want to. And when you do make dist-git or however you're going to do your stable releases, it will say, all right, well, my tarball is now coming out of whatever tag is specified in Fedora 7.x, and then I'll build my patch list on everything that I'm carrying that's different. And so you can manage that forever and not have to worry about doing a lot of manual updates and changes there. Last thing I really want to talk about is there's if you know Thorsten, nerd, and Fedora, he has been maintaining the vanilla branches, been maintaining the Linux Next vanilla trees and things like that. They're all in Cooper. But he's also come up with this great script called Archify. And what this Archify script is, that I've linked to here, Archify will take any upstream kernel tree and basically throw the Red Hat directory Archify stuff on top of it, so you can just build your RPMs and manage it in the same way you would any other Fedora or Red Hat tree. It's useful if you want to. If somebody tells you test DRM next, you can use something like this and not have to worry about, oh well, how do I deal with all of this? So, at that point, that's kind of all the basics that I have. So if anyone has any questions, we've got like a couple of minutes left. So, questions? Oh, sorry. There don't seem too many. Okay.
So, I'm sure, as you're already aware, the kernel's been under a ton of CVE pressure as of late. So I'm curious, like, both, how is Fedora handling that problem currently? And I'm sure, everyone could use more help in that space. How can, the call to action for this room, how can people help solve this key part of the OS?
That's the normal way that the kernel is handling CVEs upstream is they will not assign a CVE until something has been patched and unstable. Which really means is the Fedora kernel never has any CVEs, except for in the last month when everything happened. Technically, those CVEs were not actually, like there were no CVE numbers applied until, but there were times where with Fragnasia, I think I built 5 kernels in a week. And that was, it's the messiest patch list changelog I've had in a long time, to be honest, because I would apply a patch and then revert it and apply the V2 and revert it and apply V3. I built 5 kernels, just in 1 week trying to push that out. So we're going to do everything we can to make sure you're covered. How you can help, other than letting us know if you see something that we maybe didn't see, I'm not entirely sure. But yeah, we're going to try to make sure you're covered in every possible way. And the nice thing is my turnaround time, other than when the S390 stuff was down and we had a two-day issue, realistically my turnaround time is about 8 hours for a kernel right now. That is the reason. So we do have, if you wanted to do, say, an RT build, if you wanted to, real-time build, if you wanted to do all these things are in the spec file, they're fine, they're enabled. The reason we don't ship them in Fedora is because exactly that, CVEs. I cannot start a build and then wait for 6 builds to happen because it's all serial. So hopefully at some point that will change too, and we've asked for it. But in the meantime, it's like these things are defined, they're enabled. You can build your own kernel if you want to do these things. In fact, even in the kernel arc tree, I maintain a long-term stable branch. When I say I maintain it, I'm not backporting the CVE fixes to it, but it's there. If you want to build it, whatever is upstream is guaranteed there, and it's merged with the Fedora patches, so it works as a Fedora kernel. I just don't, like I said, we don't build it and ship it. So that's one of the reasons. Like I said, the CVE fixes, I try to get them out as quick as I can. And sometimes that means, it's 2 in the morning when I'm pushing a fix, or as Justin will attest, he was talking to me about some of the AI stuff. It was like 2 or 3 a.m. and I'm waiting for builds to finish so I can push them out. So we do try to get them out, but it's I'm not sure how the community can help in that method.
Just a quick follow-up, how you can help is if anybody is hacking on Koji, we have a patch for running these 6 builds in parallel in a work for 3 or 4 years.
Yes.
But we have no hands now, so if someone wants to take it and continue on that, we will be happy.
Yeah, we've asked for it for a long time, and actually, so RHEL also has had these problems, and maybe that will force getting that patch pushed, because the reason it was delayed for so long is supposedly everything's going to Conflux. The problem is kernel's still not in Conflux, and now we have these SLAs, so we'll see. Right.
Just saying that the conflicts will have the exactly same problem, so we will need another patch there.
Yes, absolutely.
I assume you don't have anything surprising to say here, but it has come up. What is your opinion on building alternative kernels within Fedora?
So the policy against alternative kernels exists for a reason. And the big reason is, from a support standpoint, I don't just build kernels and push them out, right? Every bug that comes in comes through me. I read every single bug, I promise. Even if I don't comment on them, I read every single bug that comes in on Fedora kernels. The problem is when you have multiple kernels to deal with, and I have to process, right, well, which kernel is this against and which is this? That's why we don't do them. So like I said, I am maintaining a long-term stable branch for the people who want to build it themselves, and that's fine. But as far as a built, signed, secure boot kernel for Fedora, I am pretty strongly against adding another branch, and I don't see anything that's going to change that. Even talking to the SUSE guys, I don't know if Sean's in the room, but he was saying, oh yeah, long-term stable doesn't actually seem to fix anything for them. They added it, they've got it, but it doesn't fix anything for them. Right. So, I mean, unless, like, if I knew that it was going to solve a lot of problems, I might actually push for it. And frankly, since it's just me, I can kind of make it happen. But I haven't seen it solve any problems.
So on the it's just you thing, you're awesome, thank you. But if someone would like to get involved and help, so that maybe you don't have to read every single bug, or something, you'd feel comfortable that somebody else is there. How would they get involved in kernel and Fedora and helping you out?
Right. So there's actually two things there, and I'm actually very hopeful soon that it will not be just me. So I don't know if Augusto has been doing builds, but doing builds is not much of the job, right? It doesn't take much off of me. I believe Augusto is going to be trying to do a little bit more there. And then we do have someone else who's coming in to the RHEL kernel maintainer team from support. Has been in kernel support for 10 years. And so the biggest thing is, like I said, the builds are not the job, really. It's the bugs and dealing with the bugs. So if somebody wants to jump in, look at Bugzilla. Look at Open Bugs Against Kernel and see what you can do to help. If you tell me you're working on a bug, please do. If you want to submit merge requests, so like all of these branches do exist on kernel arc. You can submit merge requests, and I am more than happy to review them. I would love to have your help, please. Anybody who's willing to help.
So it's not really a question, but just following on that, I get to work with a lot of different kernels and distros, and you're doing an amazing job. And for getting fixes for new hardware in, thank you, really appreciate it. And for anybody looking to help, I do the merge requests for fixes for our laptops, and yeah, it's amazing. So thank you.
No, thank you, because realistically, I mean, I want Fedora to work on everything as well as it can, right? My goal is, I mean, you're a great vendor, but the truth is, like any vendor, I just want all of my users to work, and you make sure that they work, right? You are sending us patches, so I'm grateful for it. I love it.
It's an easy process.
I try to be. We don't have all of the necessarily overhead that RHEL does, so I can kind of do some of those things. But yeah, I really do. I want to make it as easy as possible. If there's something you want, even with config changes, like I've had people ping me on Matrix or IRC and say, well, can you change this config? And I was like, well, yeah, you could file a bug, but I could just do it right now. And it doesn't take anything.
We're out of time, but please catch up with him.
Yeah, I'm available. I'm around.
Fedora.
Thank you. Are you gonna use that? Oh, yeah.
Okay, we are starting. Okay. Hello. 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 Okay, please settle down. We are starting. So, Kashyap Chamarthi, Principal Software Engineer at Red Hat, presenting state-of-the-art Fedora on RISC-V. Please. We can start.
I think just come right in if you can. Hello everyone, I work for Red Hat. My name is Kashyap Chamarthi. Oops. That's okay. So hey, I'll try again. My name is Kashyap and I work for Red Hat for about 15, 16 years, 17 years already. And I work in the community Linux engineering team on all things RISC-V enablement. Before that, I was doing virtualization and OpenStack. So today, what is this about? Just give an overview of what we're doing in the RISC-V ecosystem for the last year, and also a general overall view. So today, my co-speaker David is not here, unfortunately. He decided to do Fedora 45 rebuild instead of doing this talk with me. I think he's following along, maybe somewhere on his stream, so you'll see the spirit of him in the room. So yeah, David couldn't make it, but it's a talk of the community effort. So yeah, what are we going to talk here? So just give a rough overview of the RISC-V ecosystem for those who are not familiar with it, and where are we with the hardware status, some benchmarks we'll go over, and kernel stuff. So how do we deal with kernels? And the last one is what is the path towards RISC-V becoming a primary architecture in Fedora? But before that, it has another prerequisite, which is it should get into the primary Koji. So what does the path look like? It's being discussed, and we want to work with the community, obviously. You're working on it. So yeah, that's the rough outline. RISC-V ecosystem. So at the core of it is the open, what is RISC-V, right? At the core of it, for those who are not familiar, for the core of it, there is a open instruction sets architecture. So it's an open standard, but the implementation of chips can be proprietary as well, or open. So it is, that's a distinction. And open, the RISC-V Open ISA is governed by RISC-V International, or RVI. And there's a neutral body, they're located in Switzerland. And there's a whole bunch of members that are part of this RISC-V International group, many companies, and they keep the governing element of it. They produce the whole sort of specifications. All the ISA is developed openly on GitHub. So that's the RISC-V International job there, or it's non-profit org. So. And then you have RISC-V IP vendors. These IP vendors produce they design the RISC-V cores, which are then implemented by silicon vendors like Tenstorrent, Sci-Fi. Sci-Fi doesn't do chips themselves, but they produce the IP cores. However, Tenstorrent also does both IP and silicon. Then there are other vendors like SpaceMate and Star5. These are several Chinese and a few American vendors, but a couple of them were acquired recently by Qualcomm. It's a evolving ecosystem. ARM has been around for 40 years. RISC-V exists for about 15-something years. So that's the other two angles, the IP vendors who produce the cores, and the chip manufacturers go and produce the system on chips, the boards, actual boards that we end up using. And then there is the RISE project, which stands for RISC-V Software Ecosystem. And that is like the Linaro of RISC-V. So who knows what is Linaro here? Okay, yeah. For those who are not familiar, Linaro is, in the ARM world, they're sort of the in-between party that lets contributors and maintainers work on upstream projects. For example, QEMU project is maintained by one of the main maintainers. The folks work for ARM, but they work via Linaro. So, and ARISE, the whole goal of the ARISE project, ARISE initiative, is to is commercial readiness of open source software. So later at the end, I'll talk a bit more about their funding. So there's some funding available. I'll show you at the end who and how. So they let projects be ported to RISC-V or optimizations. So that's the whole main focus of ARISE is commercial readiness of open source software. And then there is Fedora. Fedora does the integration, as we all know, of upstream software and produce a solid, stable operating system for developers and many others. So, a couple of things. So there's a lot of jargon in RISC-V ecosystem. I just want to keep it the most essential bits here. The first one is I'm used to sometimes the microphone, the lapel one. No, it's okay. It's okay. It's just a hassle to keep it going. So yeah, RVA23 is the most recently frozen ISA specification, and that's a couple of years ago. So that's it's an ISA profile. A profile is essentially a set of base ISA features and some mandatory extensions like support for hypervisors and support for math-intensive workloads, which is called a vector extension. So that's the core of RVA23. That's the most recent ISA specification, and that just defines the base hardware baseline. So sort of not to fragment the ecosystems, because it's such a flexible ISA that so many possibilities are there, but you can get lost in the Wild West with it. So the profiles sort of try to give like a bundle set of features that people who are implementing chips can target that. And then the other spec that is more important is the server platform spec. It's a non-ISA specification, and that was recently ratified, meaning frozen. It's again a set of requirements that give you base common sense server features, for lack of better phrase, like PCIe. If you're implementing serial console, for example, you need to have serial console for baseboard management, or UEFI and ACPI. That's one of the main things. And again, the RVA23S64, that's the set of base extensions. So it provides operating system vendors to target a single image, that single binary that can work across compliant hardware that implements this spec. Yeah, this is a community work, so I just want to give a shout out to all the folks that are doing the good work there. David is right now rebuilding 45 on Fedora RISC-V metrics. If you go there, you'll see him debugging or saying whatever that is on fire. And so yeah, I'm here representing many of much of the good work that's done by many folks. A bit of a timeline. So it's 2016 is when RISC-V Bootstrap started in Fedora. I started last year, actually, around March something. And Richard Jones from the Fedora community, I think many of you may know, or some of you may know here, is a prolific contributor. Richard Jones started it back then, and David started right after, so he's been around also as long as Rich. And then at the beginning, they were like emulated builders, and slowly we got real hardware that is not that fast, or it takes 7-8 days, I think, to build some packages, maybe longer. Then, of course, the middle years was all porting the 20,000 plus 24,000 packages of Fedora, I guess, to RISC-V. There's a lot of grind involved there, so it's still going. There's a last mile work involved. We'll talk a bit about that at the end. And then what? Okay, yeah, we also got, as time passed by, we got more and more vendors starting to implement chips that you can actually use in build system. So 25 was particularly interesting, not because I joined the effort. Until then, the RISC-V secondary Koji server was running. David was maintaining it by himself, and we moved to official Fedora infrastructure. And that's risc-v-koji.fedoraproject.org, and that's we also had Fedora 42 release at the same time of the primary architectures, so that's also a first time thing. There's always, at this point in time in RISC-V life, this delay is expected between the primary arch and the secondary architecture, because yeah, there's builder shortage sometimes, and it's not yet in the primary Koji, so there's always, you need to debug something, so it's completely expected and normal behavior. But it turned out for Fedora 42, it was all on time. And there was also RHEL developer preview, but this is not the forum to talk about it. RHEL 10, that was released, the first one. So there's links out there that people who are interested in it. There's another one that was released, a follow-up to this preview a couple of weeks ago, or last week even. And 43 was, that in 25 we had some problems during Fedora 43 rebuild, but much of it was resolved by just working with the upstream maintainers of bin noodles. There were also issues with debug edit. So all this were sorted out, but this takes time and effort, persistence. We recently released 26. Fedora 44 images were out, about a month of delay. It was smoother than Fedora 43, but there were still some hiccups with GCC issue. There was CMake transition. David probably will recall more as he's doing a lot of this stuff. And one of the other interesting things is Copper CH roots, and I'll talk about it a bit more. It's emulated builders. Okay, so that's what I was referring to in the previous slide. So the rebuild is done, the images are there. Phoronix picked it up a couple of days ago. One of the other things that is particularly new in the Fedora 44 timeline is the so-called Omni kernels. I have a whole section about it, but very briefly, it's a single kernel that can boot across several different boards, so that's the basic idea. I will show you how it was before that idea came into existence. The Koji server I was mentioning a bit ago, that's now in Fedora infrastructure. And there's, of course, a lot of work involving changes from, there's a secondary dist-kit that is maintained with some specific patches, and that need to be ported over to the main Fedora dist-kit. So there's a lot of that work involved, and most of it is done, but the last mile difficult bits are there. Marcin from the Fedora RISC-V community is doing good work there. I have a slide a bit more about that for those who are interested to chip in with debugging and so on. One of the other things is the building the images. So before, before early 25, they were using local images. So now it's all built with classic Fedora infrastructure, Kiwi and Koji, the whole build. I have not done it myself, but there's David did it, and Andrea from the community did some of this work. So if you're more interested in details, just hop on the channel, metrics channel, to figure out. The last point, the Fedora Copper builders, that's the QEMU builders to run, to build kernels, and you can build other things too. So you might think, emulated builders will be deadly slow. So, but it turns out there's a beefy enough machine that can run, that can build the kernels. So these are 5-6 hours or something like that. So it's quite fast compared to what hardware is doing. But I'll get to build times in the benchmark section. Okay, a bit about where are we with hardware. So before I go on, earlier at FOSDEM last year, there was a really interesting talk by Emil, kernel engineer at Canonical. He gave an overview of these chips and boards from 2018 to 19. Sorry, not 19, 24. You can tell how awake I am. 2018 to 24, so I don't want to repeat all of that. You can see that talk. He gives a good overview. This is covering the boards afterwards. So this is one of the main machines that is doing most of the builds in RISC-V Koji. It's i5 vendor, and it looks like a scrappy machine on my desk, but the dressed up version is quite nice as well. It's server chases and so on, but I was a bit lazy because I was fiddling with some things. And that power is a bit overkill for this, but I bought it because I have another RISC-V accelerator card that I want to use, so it's not just for this. A lower power can also be fine. And most of Fedora's builds, it's reliable. Most of the Fedora's builds, especially the heavy-duty packages like GCC, LLVM, sometimes kernel 2, because Fedora only accepts native builds, right? So that's one of the golden rules. So of course, kernel is also built on this hardware, physical hardware. So it's based on a semiconductor maker called Iswin, and much of these peripherals of this board are upstream. Some are not yet. If you're interested in what those are, you can check out the links at the bottom. Throughout the talk, I have links for those who are interested in more the gory stuff. I think serial console will work, and maybe the clock was also merged, so I didn't check the latest. I'm not tracking so much going on, so not always. That's the other, oops, ran too fast. That's the other vendor, 10-Star, and they're a very interesting company. Their CEO is Jim Keller. He was CPU legend. He is still legend in the AMD CPUs. He was designing some of those, so they really know what they're doing. What is also interesting with 10-Star is they're also good at open source software. They working with the Linux community upstreaming. So this board is a bit of a novelty board, but it is still interesting in the sense that it's an accelerator card, AI accelerator card that you can plug into a PCIe 5.0, the faster one, to get the max bandwidth from it. I have one of those. I haven't tried it yet because they just shipped it a couple of weeks ago. And my server is too old to plug this in. It's 3.0 or something. But you can plug this in something called an eGPU dock. It's a kind of docking station where you hook this up, and it has a Thunderbolt port, so you can drive Linux. And most of this board is upstream. The patches are there. You can even boot the mainline kernel with limited access with like serial console with OpenSBI, stuff like that. But still, it's quite interesting in the sense that they're working to upstream stuff. That's the important thing, right? When the software and the hardware are working closely together. So that's. They also have. I saw at the RISC-V North America Summit last year, racked up version of these, so you can get beefier with liquid cooling and so on. I have some images that I wrote in my trip report. I can link to that. It is linked actually at the end of the references. And this is interesting because this is the most recent board based on the latest ISA spec. It looks kind of not very robust, kind of looks small, but it packs quite a punch. Why? We'll see in numbers. So this is compliant with the RVA23 specification, and it supports hypervisors and math-intensive workloads for AI and ML stuff. And it does provide a pretty solid performance leap and a meaningful leap compared to our previous workhorse machine from Sci-Fi P50. So what that is, we'll see. Again, what about upstreaming? They're doing really good work, the SpaceMate, in terms of working with upstream kernel. Their device tree blob is already in the upstream kernel. They have a whole wiki page, actually. If you click on the working progress link, you'll see what peripherals are upstream, what are in progress, and so on. And this is actually available to buy, right? It's not just somebody who has a special access. The whole point is the ecosystem will only work if developers can buy this. So it's available to buy. And we already have it in Fedora Koji infrastructure, and one more is on its way. And it's a bit of a hybrid machine in the sense that it has 8 general purpose cores and 8 AI cores. So the general purpose cores are what we care about in terms of building Fedora. So we'll see the numbers for that. This is another board from a vendor called Milk5. This is based also on the chip that I mentioned in the previous slide from SpaceMate, the K3. So it's same system on chip, but they have their own some additional peripherals. I don't have access to it yet, but I was told just yesterday this is available to be bought, and some 8 or 10 of them are being procured. So this is same performance should be as the previous one, SpaceMate K3. Also RVA23 compliant because the same system on chip. We'll see what that is in a minute. This one, I talked about 10-Torrent a bit ago. This is not the hardware itself. This is their 10-Torrent's most recent ISA RVA23 based board. Atlantis is the board, but this is the FPGA. The FPGA running the ISA core from this Atlantis board. So that FPGAs, as some of you or all of you may know, are programmable chips that will let you test your silicon before it goes to manufacturing, so you can catch the bugs beforehand. Otherwise, it gets really extremely expensive. And these are pretty powerful FPGAs. It costs almost as much as a sports car, apparently. I don't know which one, though. But and this is supposed to be at the end of this this year or early 2027. That's what at least the 10-strong guys I talked to. Last week, actually, I was in Bologna, Italy, where we had RISC-V Summit Europe. So there they said that. So we will see if that shows up. And the board that is, the emulated board is merged in QEMU. If you're using QEMU, you can actually try it out and see the peripherals and so on if you're interested in that kind of stuff. Of course, what is most important, as always, the Linux upstreaming, that is always in progress, or already in progress. 10-strong folks are good at working with upstream, but the boards are yet to come. They had a small glitch or something in silicon production process, but it's on its way, is what they told me. These are a few more boards that I saw last week at RISC-V Summit. Again, some of these are older boards. They're not very interesting if you're interested in the middle one is not interesting now because we have the most recent hardware that can do builds much faster. But these are people are still using some of these. The middle one with racked chips, you see, that one, there's a cloud vendor called Scaleway, small one in Paris, and so they provide a RISC-V service for developers doing wiring up their software, porting their software to RISC-V. So there's a couple of other boards. I don't have access to all of those boards myself, but yeah, some do. If you're interested in what board to pick, we'll see in a minute. Okay, we've seen some pictures of these boards, but how do they actually perform? Let's look at some of the benchmarks. P550 is the current workhorse, just a terminology, and K3 is the most latest hardware. So this is just a basic XZ compression of Fedora ISO, and see how it compresses. As you see there, the single core performance is quite a good leap. Now, as I mentioned earlier, the K3 hardware has what it calls 8 general purpose cores and 8 AI cores. You might think, hey, if I run on AI cores, it might perform faster, but it's actually not so. So I ran a test where running the same benchmark of compressing this ISO file, Fedora 43, I guess, when I did that. On the general purpose cores, it outperforms it by like 3 or 4 minutes. I talked to the hardware vendor, and they said it's because the AI cores, the L2 cache is sort of smaller, but on the general purpose cores, it's slightly bigger. So there's details, and not all workloads work on AI cores equally. So this is expected behavior, so the guy confirms. That's the basic exit. What else? But we're interested in builds, right? Fedora is interested in builds. So these are the most heavy-duty packages, or at least the top 3, top 4 probably. Kernel, GCC, glibc. As you see, if you pay attention to the middle, GCC takes 5 days and 13 hours today on the most our workhorse machine until now. But the most recent hardware slashes that time by two-ish days. So that's what I was referring to as a meaningful performance leap. It's not there at x86 levels, obviously. It's a slow grind, it will take some time. You need another leap in performance. So that was quite interesting to see how it performs. So I was doing benchmarks throughout the last weeks for this talk. There's a Fedora Forge ticket with more details if you're interested in it. Sometimes I have to do a small intervention like disabling debugging for 1 or 2 packages, but most of it is just classic Fedora build. It's nothing else added to it, nothing else deleted. In all these benchmarks, we use just the classic 8 general purpose cores we care about. the AI cores were idle, and when we do use AI cores, I will flag it. But so for builds, they will all be done on the 8 general purpose cores. So you can't think of it as, hey, there's 16 cores, I can combine them all. It kind of gets messy. So the recommendation is just to run on the 8 main cores. But for other, if you have math-intensive workloads, they can be done on the AI cores. So I haven't done those benchmarks yet, just lack of time. But that's some other people have done on the internet, starting to do some of the more intensive LLM inferencing, stuff like that. So you can check that out. Okay, this is the same slide as before, but I just added in the ARM in it, AX64 numbers. So to sort of zoomed out version, how we perform with ARM, right? The blue, light blue one. As you see, it's about, currently it's still not there. 3 hours on the latest hardware, 3-ish, and on AX64. These are whatever we're using in the primary Koji system. So that's like about an hour. It just means it needs another leap in hardware. So just have to give some more time. As I was mentioning at the beginning, ARM had 40 years to be where it is today. And the hardware vendors have to keep producing the silicon. It also hinges on them. So that's the sort of comparative numbers. GCC, again, 14 hours versus 2 days, 2 and 15. That's still quite off. That needs improvement. So overall, the system level software is about 3-ish x slower than ARM, what we have right now in Fedora build system. So that's just a perspective to see where we are. We know that it's relatively slow, but it's evolution, not revolution. Okay, some more builds. A bit user spacey. Well, LLVM is not quite user space, but gives a perspective there. OpenSSL, this was interesting. So as you see there, it has almost 10x speed compared to the P550, our current workhorse until recently. And that's apparently, I learned about it last week. I didn't know why. OpenSSL has a lot of handwritten assembly code that optimizes these vector stuff. That's like a SIMD in x86 equivalent. I'm not an expert in those topics, but there's write-ups on this elsewhere, so I can link to it if you're interested. I can point to that. So that's a gain. So sometimes you do see this sort of outsized gain for some user space packages. QEMU, that's an important package because Fedora heavily uses in Fedora QA. QEMU used extensively. Developers use them. So that's also reduced by almost 6x. So that's quite nice. LLVM, that's also 20-ish hours to 9. That's quite a good improvement because LLVM is one of the packages we need. There's some last mile work left. So we've been chipping away at it for 6-7 months. So essentially, some test suite failures. You just have to work with upstream, get the patches merged, debug the failures, rebuild the software with dedicated sort of targeted rebuild. You don't do the entire rebuild, so you don't waste all the 20 hours of time and the compute, but just targeted rebuilds. So that's the user space-ish software. Oh yeah, and these are not super scientific benchmark, but they're close enough, give a good enough perspective. Things like what storage is being used or clock frequency, they affect the benchmark. So just don't take this as like super serious, super scientific benchmark, but this is just good enough for developers to understand where we are. Okay, this is, again, same theme as before, zoomed out version of compared to ARM, where we are, the same 3 packages. So it's about OpenSSL, again, 8 minutes. It's not a lot, 8 and half the time. And QEMU is 26, again, half the time compared to the latest hardware on RISC-V. So it's, as we saw, system software was 3x, 3.5x slower, and user space is about 2-ish slower. So if this trend continues, in a couple of years, it should match that. So we hope the hardware vendors will keep producing silicon. some more benchmarks. So I'm not going to talk about all of this here. We've had just this. I want to give a basic perspective, but if you want to dig into the details, for the Fedora build benchmarks, I'm maintaining a ticket on the Fedora forward, so you can go check out all the details with each benchmark. If there is an intervention, what is that, and so on. The other thing, for those interested in AI stuff and ML, the math-intensive workloads, the vector benchmarks are interesting, like system calls, how they're performing. So for this, Olaf Bernstein from the RISC-V community is doing really good work on maintaining really detailed benchmarks. These are really super scientific. When you click on the link, you will see how this is like a standard it has become in understanding how the vector stuff performs, how you can rely on AI, how AI workloads actually do. So for these kind of things, the low-level details are in these benchmarks. And there's some older board benchmarks from our own folks from Fedora community, Rich and Andrea. So these are also available if you're interested. Now, what do you want to pick? What board do you pick if you're getting started? The answer is it depends what you're trying to do. If you just want to get an idea of how these things work and you don't have a lot of spare money to burn, you go with the basic Vision 5.2. So this is from a company called Star5. What is interesting about this board is most of it is upstream. I think you can boot unmodified upstream kernel on this, so you get a good sense of that. And it's 200 or maybe less euros, if I'm remembering correctly. I don't have this machine myself. So that's Vision 5. And if you're interested to understand, if your eventual goal is to work on low-level AI workloads, optimizing those kind of things, then the Banana Pi, the BPi F3, that is interesting because it has the vector extension support. So vector extension is for math-intensive workloads. So those who are doing compiler stuff were using this board in the beginning. So this is the go-to until recently, because now we have better hardware available again. And this i5 P50, that's been the workhorse for us in the Fedora RISC-V community so far. So for all the heavy-duty packages, we use this. And we are moving now slowly towards the last one mentioned over there, the K3. That's the hardware. If you're a developer interested in cutting-edge hardware, want to do a lot of builds, a lot of compilations, just try out some of the vector extension for AI-style workloads. That's the board you want to have. It costs about 700 euros and something, the board, the K3, and plus peripherals, NVMe, something like that. So that's the sort of a rough idea of what you want to pick. And Tenstorrent's Atlantis is also, we're looking forward to this one. This, when it arrives, end of this year or early next year. So that's a rough overview of what to pick. But there's more kinds of boards, but I'm not interested in many of those. I don't have access to them, but they're like smaller boards, embedded boards. RISC-V is in many places already. Probably it's already in the phone that you're using today, but probably as a small microcontroller. As I said at the beginning, the ISA itself is open standard, but the implementation of the ISA can be proprietary. So many vendors like Qualcomm, NVIDIA is switching as well to RISC-V in some of its Falcon or whatever it's called. So yeah, Google also, I forget the brand name. So it's already used in many ways, but you just don't realize it. Okay, this is the kernel part. I don't know if Justin is here, but it's okay. He knows all of this. What are Omni kernels? So this slide looks scary. It's a lot. So before, until recently, our kernel guy, Jason Montleon, in the Fedora RISC-V community, is taking a lot of vendor trees. There are some specific patches that require for some boards, and is rebasing them on the mainline kernel and applying the RPM-specific details to it, and then producing images via RISC-V Koji. It looks like a lot of branches, but the churn in the vendor trees is not that much. But still, it's still a lot of work because you have to rebase them. And this is not sustainable to keep doing it. So the solution there is the Omni kernel, or what we used to call unified kernel, but that kind of confuses with unified kernel images. Some of you may know that. So we wanted to avoid this confusion and instead chose the Omni word, Omni kernel. So it's as the slide says, is one kernel that can boot across multiple boards, about 15, 18 boards. I have a list of them. So it kind of drastically reduces the duplication and sort of consolidates a lot of this effort. So you forward port the vendor patches, make sure they work on the mainline kernel, and integrate into a single Fedora tree. That's the core idea. And Justin was talking in the previous talk about how Fedora carries no upstream patches as close as possible to mainline kernel. That's the end goal, obviously. This Omni kernel is like an intermediate step towards that. So until we get there, we have to carry some 200 patches. I asked actually the number last night because Justin asked, I didn't know top of my head. So these are necessary, but it will eventually go away once these patches are merged in upstream. Some of them are already in maintainer trees or in Linux Next or in mainline, but not yet released. 7.1 was released, so that's the status of 7.1. And you can get these kernels, you can boot them also with QEMU if you have, or if you have a board, you can try them directly on one of your boards. If you want to dig into the details of the patches, where what are we carrying, what kind of patches, if you're a kernel developer in the room, so you can look at the kernel repo, arc repo of JSONs. So that's the Omni kernel idea. So with this, the diagram we showed before becomes like this. So for now, ignore the bottom part of the slide. The top part is just, so it condenses all these trees into 1, 2, 3, and it integrates them into RISC-V Copper, one single tree, and push it to RISC-V Koji and produce the image. So it's much less work, much more consolidated, easier to manage. So thanks to Jason. So below, at the bottom of this, these are, Deep Computing has, this is another vendor. They have some laptops. They're not super performant, but again, it's a process. These framework laptops, they need a couple more trees. That's because video doesn't quite work well with that. So these trees are just for that thing. But nothing else crazy in there. So those are the kind of boards that Omni kernel supports. It's about 15, 18, I don't know, 20. But they're all, some of them are sharing the same system on chip if you see EIC 7700. So Jason is maintaining several of them, a lot of them, actually several people are testing together, and he's maintaining this list and trying to consolidate a lot of testing. So if you have any of these boards, if you want to test these Omni kernels, so come talk to us on the Fedora Metrics channel. Okay, this is the last part. So what is the goal for RISC-V here, right? The first step towards primary architecture, which will be a couple of years later, or whenever it is going to happen, is to have RISC-V in the primary Koji. So this is a brief idea. So what are the main requirements? The main thing is you need to have rackable hardware. The current hardware, the latest hardware, you can put them in racks, but some of them don't quite have the features that Fedora data center maintainers, Kevin Fenzi and others expect. So they're coming close. The hardware vendors are working on it. So once this hardware satisfies these requirements, then they can be racked. So the rackable server hardware is one of the most important features. And we're tracking the requirements. The budget allocation is being worked out. So that's one of the main things. And then, of course, package maintainers should be able to debug their packages. Not everybody will get access right away, but some of them who may need it urgently to debug some things will get. So we need to provide access to maintainers. So there is also a ticket tracking that. And of course, not least of all, these are going to be Koji builders. So we want an unmodified Fedora kernel to run on these builders. So that's also important. We're carrying about 200 patches. So eventually, less of them and unmodified, hopefully, very soon. Very soon here is, it will take time. You have to keep it in perspective. So yeah, that's the baseline requirements. Yeah, this is the other one I said, the last mile work in the RISC-V tracker. So we have a RISC-V tracker maintained by our colleague, Andrea. and several others are contributing to it. Most of the packages, the porting is done. There's a small selection, I think 100 or something, maybe less, that needs some work, but some of these are heavy-duty packages, the kernel, shim, and LLVM, OpenJDK, stuff like that. It's what is there to do. It's the classic upstream development work we do. See if there are test failures, try to work with upstream, figure out the root cause, submit the patches and so on. So if you want to contribute any of those, there is the RISC-V tracker. Marcin, as I mentioned at the beginning, has been doing quite good work. He's picking up quite a lot of this, and I'm sure he'll be happy to help if any of you have time to. Okay, last one, or almost at the end. This RVA23 is the latest ISA spec, as we said. Fedora currently uses something called a slightly older baseline, and switching to RVA23 as a baseline is a big topic, and we have to work out as a community. So we don't yet have a concrete answer. We're still exploring, because you need a good reference platform, at least a couple of machines that are based on the latest ISA spec, RVA23. If they're out in the market, then we can decide what. Because Fedora tries to do it the right way, so we don't want to rush, and we want to be thoughtful about it. So that's an in-progress work. So if you're interested in this topic, come talk to us on the metrics channel. And what about the ecosystem readiness in terms of software? How is Linux ecosystem doing? On that, there is a whole talk by Andrew Jones from Qualcomm. He also chairs the hypervisor special interest group in the ISA. So he gave a talk, a very good talk on this topic. So I recommend you to check out if you're interested in the details. Kernel is one quick word, as it's there. The older SoCs will support the RVA23 kernels because they are a subset of the RVA23 ISA, the older RV64GC user space. So all of these details and more you can learn in Andrew's talk. At the bottom I mentioned one more, a system call. It lets you reliably detect RISC-V extensions in the Linux kernel, and this was recently in development. And again, details of this are in the documentation kernel. If you're interested in this, if you're a user space developer, want to understand what this is, check that out. That's pretty much it. So over there, this call for volunteers for getting involved. So what kind of things? Test the Omni kernels if you can. If you have a board, try to boot the images that we're producing. There's one more thing I wanted to put a plug. If you are interested in porting some software to RISC-V, open source software, and your employer is already not a member of RISC-V International, there are some funds available to do the porting. So the RISE initiative, the RISC-V software ecosystem, they have some funds. And how to get those is all documented in the links over there. So you have to describe the project, what you've done, and oftentimes it's not a lot. Wiring up in the CI, making sure basic optimization is there, and the example projects are also listed in the project scope link. So what kind of funding you get depends on that. So check that page out if you're interested in porting some RISC-V software or doing some of the CI work, or other larger, if it's a larger initiative, there are bigger funds, but it depends on what is the scope of the project. Yeah, communication, as I mentioned, come talk to us on the RISC-V metrics if you're interested. There's a forum, there's issues, so on and so forth. References, some links if you're interested. So I wrote a trip report for last RISC-V EU Summit, so what's happening at the ISA conference. So you can read some of those. And there's a ticket, as I mentioned, for RISC-V inclusion in primary Koji. What are the details? It's over there at the first link. That's the link for slides. That's all I've got. If you have any questions, comments, rude remarks, go for it. I'm going to repeat the question. Yeah, that's good.
Okay, so regarding the Fedora build hardware, are you planning to go still to the K3 and then later on switch to the Atlantis? Because Atlantis will require, I assume you will go with either x86 general CPU and then put the accelerator card there, or ARM. And then you can use the builder for both architectures?
The question is, are we going to, in Fedora Koji builders, are we going to switch to K3 and then to Atlantis? Is it, well, Atlantis is not here, so I'd rather talk about things that is already here. I always quote this Chinese saying, I laugh, it's called talk does not cook rice. So I want to see the silicon. So talk does not cook silicon. Until it's there, we can't talk about it. So K3, yes, we already have a machine in the RISC-V Koji, and another is on its way. So yeah, eventual plan is if there's a capable machine that comes, we have budget planned for it. So we'll put them in the data center to get it going.
Okay. Second question, since you've seen way more hardware than I did, and I know that there is lots of work going with the shim for secure boot. Have you seen any board already that now has secure boot firmware implementations yet?
Not that I know of. No, secure boot is an evolving topic. I think we have a bootloader specialist in the room if you want to talk. So not yet, no. Marta, you want to have a comment? You have a comment? Okay.
Hey. So assuming that the K3 hardware was the thing you could put in right now and make builders from, how many of the patches set are needed to enable those right now if that was what we were doing?
How many of the what, sorry?
The kernel patches that you're carrying in the Omni kernel. How many of those patches are actually necessary if we were going to use the K3 hardware to spin up Koji builders? Are you talking?
Right.
I'm assuming all those 200 are mostly hardware peripheral device patches.
Right.
How many would we need to carry just to spin up an unmodified Koji Fedora builder if you were to put the hardware in place today?
Right. I don't know top of my head how many are required. I think that those
Ballpark.
200 patches are all not only for K3, by the way.
Right, that's what I'm saying. What is needed for K3? What would we have to carry today?
I think the things that are not merged yet upstream, I don't know top of my head what are the peripherals and low-level component patches that are merged and what are in flight. So I can ask Jason to discuss.
It would be good because if you're thinking about K3 being the thing, we need to have a discussion about what minimum viable patch set is.
Yeah,
and
sure.
have that discussion with Forbes.
Yes.
Because if that's what gets us to Koji builders, so that we're not stuck too long there, then we should be able to have that discussion. But we need to know how many patch sets that are, especially because these really aren't going to go out to users yet. It's just for internal enablement, so we can start doing the things so that we can get things to users when everything is upstreamed, right?
Yes.
It's no different than what we're doing with Secure Boot or FIPS, right? We have to have that discussion, and we need to know what the number is.
Right, we don't know, right? We don't know if K3 will be the thing, but it is, yeah, right now. But right now, that's the machine we're working with, and we'll slowly get there. And also, these builders are not in Fedora DC, so these are maintained by community maintainers. So that's one of the paths towards the primary architecture or primary build system is to have this hardware in Fedora data centers. So that's for that. I think and early Q1 of 2027, more light should clear up. Atlantis from 10th torrent might show up. Again, once it shows up, you also have to hook it up into the DC, get it wired up, and so on. So yes, this is a conversation to be continued. But if you're interested more in how many are necessary patches, I think Jason will know top of his head. His Arc repo has the details. And I was also discussing with Justin, I keep calling Justin, mixing both names, Justin Forbes, our Fedora kernel maintainer. So he's open to work, obviously, with whatever that can be upstreamed. So we're working with the kernel maintainer as well.
Okay, so related to this topic, SpaceMeet is the designer of the K3 boards, and they do have a GitHub page with all the peripherals and their state upstream.
Yes, I actually I linked it at the bottom of the slide
Yeah.
there. So there is a wiki page. I know what you're referring to. It is linked in the slide that I mentioned about K3's hardware at the bottom of
Yeah.
it.
So the status, from my point of view, the status of K3 is quite good.
Yes, yeah.
They are working really hard on getting everything upstream. Compared to K1, which is the board I was working with, this is way better.
Yes,
right now.
we're in touch with the hardware vendors. They're also responsive. If you have any issues, they're always willing to help. So that's the kind of software hardware vendor collaboration you need. So yes, you're right.
Yeah, and now a question of my own related to the benchmarks. Which kernel were you using? Was this some Bernard kernel, Linux mainline?
No, that's a
Omni
good
kernel?
question. So the host was running SpaceMate's own vendor kernel. It has some patches in there, but all these benchmarks I was running in a Fedora container. So I wanted to keep be as close as possible to Fedora user space, and it's running it's called Bianbu, their kernel, but it's SpaceMate's kernel. It's not the mainline kernel, but yes, it's the user space is Fedora user space, all of it. Any more?
Is the K3 speed acceptable for the users and runnings? Because it means at least mass rebuilds taking 2 or 3 times longer, or will you be waiting for the next generation?
So the question is K3 enough for regular Fedora packagers? Yes and no. For most packages it's okay. If you're doing the builds, it's yes. The answer is yes. I would say it's enough. If you're a developer packager wanting to make sure your package works well, it's optimized well, I think I would recommend to get it. And even the Omni kernel boots on it, so you can get it and test your stuff on this.
Yeah, I mean more the speed, because if we will be doing the mass rebuild for the next Fedora release with primary architecture RISC-V, it will take a lot of time. Was this discussed somewhere?
Can you say again, please?
The speed itself, the mass rebuild will take 2 or 3 more times than the current one.
Yes, I don't know top of my head like how long it will take, but there will still be some delay depending on what issues show up. So each mass rebuild, there's a new toolchain issue we didn't anticipate, right? So you know how it goes in Fedora land if you're involved in it for a while. So just can anticipate them and have to work with the right maintainers and solve them and go on. So, and it creates a delay because when you're not in the primary Koji and it's not blocking, so the lag is there. But so far, from what we're seeing, it does provide meaningful performance improvement. But David did point out the day before, my co-speaker, some packages have slight degradation, but this is more like an exception. I think I didn't do like a thorough analysis. You can come to the metrics channel to understand if you want to see what that is. But most of the the big packages, as I was pointing out, the kernel, GCC, glibc, LLVM, this kind of stuff, we do see meaningful improvement.
Okay, maybe the second question now. You have mentioned that you have that separate dist-git. How many packages have the specific patches there?
Not a lot, actually. About 110. Or if you click on the Fedora RISC-V tracker, you will see the list of them. I can give you the link to that. If you scan the code, QR code, you can see the list already on the Fedora RISC-V tracker. This one. Yeah. Earth tracker, yeah, this one. Andrea has it on his page, but several people are pushing to it. Marcin especially is doing a lot of updating of it, so you can see the list there. It's about 100, 120 or something like that. So if you want to help with any of that, you're more than welcome. Any more?
Any more questions?
Okay, I think we're good.
Thank you. Thank you, Bishop. We have a coffee break for 30 minutes.
Hello, welcome everyone. It's nice to see here so many people. I am Věra Cholasta and I am here with my dear colleague Jiří Preisner. We are both from Red Hat, from the accessibility team, focused on the accessibility of Fedora and RHEL. We are not alone. We have many colleagues, some of them sitting here. Some of them are at home listening. And today, we would like to present you updates about Fedora Accessibility Test Days, explain why we would like to do or why we do a separate accessibility test day, what is the situation, manual testing, some information about automated testing, and future plans. And let's start. So why do we need a separate accessibility test days? Accessibility is a complex set of technical requirements that demands rigorous testing. And we have several reasons for that. First, of course, ethical reasons, because we need and we want to have our software as much accessible as possible. Other very important reason is legal, because we need to follow compliance with section 508, what is Federal Electronic and Information Technology that covers access to federally funded programs and services. WCAG Web Content Accessibility Guidelines and European Accessibility Act, followed by European norm. For example, Lenovo, they have product accessibility pages, and to be honest, I hope I will not break it when I will try to. I have. You can see my accessibility setting is not good for this because and we will wait a second. You will see there product accessibility statement for products that is offered by Lenovo, and there is mentioned Fedora, so you can see if someone offers a product, it needs to be followed by the accessibility, but definitely it's not cooperating for me, so definitely we will continue. Okay, slide. Perfect. So, and other motivation for us is to have better feedback for users, because we expect, or I hope, if we would have regularly accessibility test days, people can give us more concrete and direct feedback for that. So next slide. And moving to test plan design, we start with Fedora test days in 2024. We have some base accessibility test plan, but definitely we need to expand them. Our goal is to have test plan that follow compliance in the future. And what does it mean? Here we have VPAD, what means Voluntary Product Accessibility Conformance Report. And this is a huge document, about 50 pages long, and you have there plans how to evaluate product to be accessible. There are 3 sections, as I mentioned before, that follow Section 508, WCAG, and European norm. And the risks of that is that we need too many criteria to cover. So it's very time consuming, and for presentation how long it takes. So evaluate one VPAD for Fedora, it takes around 14 hours. So it seems that full screen will work, I hope. No, probably it won't. Oh, sorry for that. Okay. Okay, so starting with manual tests, we need to have some test manual. Reasons are difficulties in automating some test cases. We would like to have integration testing, so it means many options. And we need special hardware, like Braille display and Braille printer. We have started updating our manual test cases. We have started with Braille terminal, and we divided it to 3 sections. First is Braille terminal in console that verifies functionality of Braille displays. Yeah, díky. Yeah. Thank you. So outside any graphical user environment, Braille terminal X window driver, and that's very functionality of Braille output in a graphical user environment using a virtual Braille device. This allows to test the Braille terminal plus Orca cooperation without physical Braille devices, because these devices are pretty expensive. And Braille in desktop verifies functionality of Braille output in graphical user environment without physical Braille display. Other steps is split Orca test to more detailed tests. You can see here many options. Definitely test cases and test scenario expanded. Accessizer, the update of this test case took only small updates, but still some of them was needed. And you can see new tests that should follow as well. According to this, I would like to say all this functionality will be, or I can invite you on DevCon workshop, because we will describe there all these accessibility features, and we would like to have tests for all of them. And definitely this part or some of these tests could be automated, of course. So now I would like to give word to Jiří, who
Okay,
will
thanks.
cover automated
Yeah,
part.
so why to automate? As you heard, evaluation of the ACR takes like 14 hours, and it's not just one-man show. It's a group of people working on that. And it's very exhausting because the norms are, you know, it's a really dry, boring text that is, it's a legalese basically. So that's one big reason for automation. Then another one is to create the conformance reports automatically, so you can see which criteria is passed or is not passed. What we are using for automation is something that the desktop team or the display team called now we have been using for, I don't know, 10 years, something like that. It's basically Doctail. Does anyone know or heard about Doctail? Okay, it's cool. And now QE Core, which is like a layer on top of Doctail that does all the stuff in the CI. It brings the logs, it brings in videos if the tests fail, and so on. So it's like orchestration around it. And okay, the next thing that I think nobody wants to hear is there are also some tests involving AI. So there is a reason why AI, I think, is good for this use case. It helps to describe pictures. Nobody does that, right, in the application. Like alt text is a curse word. And you can do end-to-end tests, like speech to text, and back to verify if Orca is saying what it's supposed to say, for example. And maybe more use cases. I don't know, like, where would like to see in the future for the accessibility? Anyone? Okay.
Thing you could use for this? It's called OpenQA.
Oh, the OpenQA.
Yeah,
right.
we're the guys behind
Yeah,
that.
I would like
So
to.
we would love
Yeah,
to talk to you
yeah,
about this.
it was
Yeah.
cool. Like we've heard about it a lot.
Yeah.
Many times, and I think that Fedora, especially Fedora, benefits from having two approaches
For sure,
how to
yeah.
test things.
Yeah.
So
It's
that's
always
great.
good to have multiple.
Yeah.
So we
You
would
heard
love
about
to talk to you maybe
OpenQA?
at DevConf workshop about whether we could
Yeah.
try and set something
Right.
up. Yeah.
You know Peter Schindler?
Yes, he used
Okay.
to be on our team.
Yeah.
Yeah, so we can all get together.
Yeah.
Cool.
Why not?
So do you have some suggestions for like upstream testing? Like if, for example, you are the upstream, let's say for the Fedora install or something like that, that has like possibly huge impact on accessibility.
Mhm.
Are there some tools or something that could be easy to start with and to basically prevent regressions from actually reaching Fedora? Like if you are doing changes, upstream pull requests for the stuff that has a lot of like UI
So,
things.
Anaconda is web-based now, right?
So yeah, we still have the old GTK-based interface, but nowadays it's a web view running a web application either locally or remotely. So
Yes, the
what would be your suggestions what to use for that?
Doctail and QE Core. Like if it's GTK based, yeah. That's
Like
probably
technically it's
it.
Firefox running the web UI stuff. So when that's
But
technically GTK.
if it's web UI,
yeah,
then there are web frameworks that can test accessibility. But we are not using that. We are focused more on desktop, and the web stuff is in the norms. It's I would say the norms are primarily focused on web stuff, but we don't use that. We just use a subset that fits the desktop. But there are frameworks for desktop for web automation, and they focus on accessibility too. And frankly, it's easier because we have the area labels if they are there. It's easy just to put them there because it's basically HTML attribute. Yeah, so that's easier, I would say.
Thanks.
You have more slides to cover, or Q&A is good?
Other questions there?
Yeah.
Okay.
I'm really happy that somebody mentioned the installer because, yeah, it's kind of interesting to hear that it seems that we are not testing accessibility on the installer, right? At least not the automatic way. So are you doing any manual testing of the installer?
Yes.
Okay. Like specifically accessibility?
Yes.
Okay, that's good.
I think Pavel Vacek or Lukáš is here.
This is what I think that we could do better as well. Okay.
And it's definitely a problem that we know of. Yeah. So any other questions?
I've got just one a little bit off-topic question. Like we in our team are developing or more testing the smart card integration. We talked probably with your team and also with Adam about OpenQA and about Doctile, but we ended up creating something custom in the end that is somehow talking. It's not. I think it's not even running in the VM, but it's like emulating the stuff through some kernel modules. I don't have all the details how it works, but it's also something that might be like another way or approach of testing, and it might also help with the testing of accessibility. Because from what I understood, the way how you are testing through the accessibility API,
yes,
which is not the same thing that might be showing on the display or showing otherwise. So you probably know what I'm mentioning, but that might be also something that might be helpful for some other teams if you want to know how else the stuff in GUI can be tested. Please talk to me, or I will send you to other people who know that.
That's great, actually. Thank you.
Maybe what I can say for that, from the question from audience, we can see that we have many approach and options how to test accessibility. And we don't have a single approach that would cover everything. And it's amazing because we can use all of this option, and together we are capable somehow cover as much as possible. And I think that's nice, but definitely it's a lot of work because we need to have manual test, automation test, and of course covered by different tools, and each has own limits.
Yeah. And I think like for the future, if anyone wants to use like some kind of automation on the desktop, the accessibility is still crucial to that. So that's another reason besides helping other people to make the system accessible.
Hey, thanks for the talk. Are there any examples of the automated tests for accessibility, which, for example, as Fedora user, I can run after I install Fedora?
Yeah, there is a link to a repo, and those tests are focused just on the norms. Like there are some tests that are not all the tests for the norms, but they should cover each section of the accessibility norms, either US or European. So that's something to start with. And of course, I think that throughout the years, we have open sourced some of our tests that test various applications on the desktop. So you can see the Doctile automation in practice and use that as a reference.
And in case, for example, I'm maintaining some application in Fedora and I would like to try to have automated check for the accessibility, that is working, what's the best approach?
I'm not sure I'm following correctly.
Okay, so let's say I maintain a desktop app in Fedora and I would like to have accessibility check.
Yeah.
So when I update the app, I can check that it's still working.
Yeah.
Yeah. I think for now we don't have covered it, something like that.
Yeah, no. But you want to test the accessibility itself?
Yeah, I mean whether I can go somewhere and copy maybe code and use it for my app.
Absolutely.
Like what was the best approach? How to quickly get the coverage, the test coverage for my app for accessibility?
Oh, which one it is? Which one is it?
Just a theoretical question.
Like a random one. Like if actually there was years ago there was an article on in the Fedora magazine about how to use Doctail, and if you just search the web, I don't have an example ready, but you can find it. Definitely, it's out there.
Okay.
Yeah. If you use any kind of LLM, it probably knows Doctail, which is surprising, but it does.
Okay. Thanks.
Yeah, but if I understood correctly, you ask, for example, you write some code, put it to some automation, and it checks, for example, if all labels are correctly described and accessibility is followed, or?
No, it's just.
What's the simple approach to
Yes. Okay.
accessibility test for my app?
Yes. Yeah. Yeah. To be honest, this approach is more connected to end users because the compliance is created for users and how they see or use it. We see it's not exact word, but definitely this one is good question and we can think about that.
Yeah, I don't have it in my slides, but you can find documentation to Doctail or QE Core online, and there are examples how to use that. One of the benefits is that we still use the behavior-driven testing, which relies on Gherkin language, so it's like user-friendly description of what it should do, and so it drives the life cycle of the test.
Yeah. And Shushma, we have here question. Thank you so much. Yes, sorry, you had the microphone. Sorry, I haven't seen it.
Okay, let me ask this question. I tried, when you were talking about LLMs, so I tried to set up an agent that would use Doctail to investigate the accessibility tree of the application. And I realized, or it complained about some tags not being correctly filled. But when I checked visually, and I also tried to listen to the Orca output, it didn't matter actually because, for example, the button was hidden in a container that it named before. So for the user, it was still understandable. If I run that tool again, do you want to report those failures or not?
Yes, because Orca is using something like it has its own settings.
Okay.
So that's a little bit more involved.
I have a slightly different question. Do you mind if we go back to the manual test slide? I think there was one before. Yeah, exactly. So your talk is called Fedora Test Day. So if there is a new Fedora and I would like to maybe participate in testing the accessibility tools, like how can I jump on the board? Like where do I submit, where do I start the test case run or whatever?
Yeah.
Where do I submit the results?
Definitely we plan Fedora Test Day officially, like Fedora Test Days focus on different area. And when we prepare that, we will announce Fedora test days. Definitely it will be a little bit more time, week, and people, I hope, can participate. Definitely it work on wiki pages, so people can give us feedback about if something wouldn't fit or would a problem.
And the most
You'll
important, what do
probably
you
find the announcement, you will find it on in
Not the
Fedora.
announcement. For me, I feel like we suck at it, like with the manual testing
Yes.
in our beta releases, because like we are currently using Google Doc with like really, like extensive sheet of tests, and it sucks.
Yes.
And I am looking if you have like a better way how to share something with users where they can see similar bugs and so on. Like I remember nitrate, right? But like I guess this is not what you show users, right?
Yeah, I don't know if we have anything better.
Okay.
Like you mean the reports? I don't think so.
Google Doc has nice thing that you can see other people, their hardware, and you see the same issues that you are hitting, and you don't report them again. But like that's the only nice thing.
Yeah. I don't know. I also don't know how accessible is that, but yeah.
Thank you.
We are out of time.
There was a question out. Yeah.
How do you folks incentivize participation? Do you have a Fedora badge associated with these test days, right?
That is a little bit difficult. We are from Red Hat.
Fair enough.
So, and I don't know if anyone in the Fedora community, actually, if there is any accessibility working group or anyone taking care of this, definitely would be nice. It's something that, if we can, we would like to ask the Fedora guys to provide. So there is, as you say, some incentive to participate. Thank you.
I know we are at the end of our time, so if you would have more questions, please catch up outside. And thank you for all of you that you are interested in the accessibility. It's amazing, and continue working on that. So thank you.
Thanks.
Did one of our previous speakers leave a water bottle?
It's been there for a while.
Okay. Oh, it's a different conference. Anybody Debian?
All right. I will close this.
We could just leave. Yeah. You were on stage first.
That means it's licensed to say whatever I want to, right?
Yeah, exactly.
That's great. I'll take that.
And if it's bad, we're not taking the credit.
All right. Let's see how this goes. Will magic happen?
I think they may have to flip you. Now that everybody sees your speaker notes.
Oh, I know. That's dangerous. There we go.
You can look down.
Yeah, I can.
It's like so suave.
It is.
Look at that. Yeah, that would actually be pretty good. for it. I was going to move this a little that way, just so that the notes get a little bigger.
And I should make sure it's do not disturb. Okay, good.
Okay, good. I was trying to figure out how to do that, so I was really glad we used your laptop. You probably knew.
So you want me to do the intro slide? You want me to do the intro slide?
I don't care, but I think we're supposed to start.
All right.
We have to start now.
Okay, then I can,
Yeah,
I can
you
do
gotta
the
do
intro
it, dude.
slide, and then
Do
we
it.
can do an awkward shuffle. All right. Hello, everybody. Welcome. I'm Jeremy Klein. With me are Brian and Ruben. Sadly, Sandeep couldn't be here today, so you'll have to make do with the three of us. And today we're going to talk about what Microsoft has been up to in the last couple of years in the Fedora community.
I'm going to ask you to tell us what team you're on, or how you're here, or why.
Okay. Yeah.
He's going to speak there.
And I'm on the Community Linux Engineering team at Microsoft. We're all on different teams, so we'll all introduce ourselves.
I'm Ruben Olinsky. I work on the Azure Linux team at Microsoft.
We lost our slides.
Oh.
Oh, I probably hit spacebar or something.
I'll get it back. Why don't you introduce yourself?
Sorry. I'm Brian Exelbeard. So I officially am a product manager, which is weird as a title because my real job is to annoy engineers who contribute on behalf of Microsoft to upstream Linux communities, including the Fedora community, the Debian community, and Flatcar Linux. I've done jobs like that a lot. A lot of you know me from doing that. We have slides again. Okay, cool. It's not weird that we annoy engineers. I don't work on any product, but we have a small number of titles, and so that's the one I got. So people are always like, oh, you do the thing, and I'm like, no, I don't do the thing. I don't even know how to use the thing. So 2 years ago, we created the Community Linux Engineering team, and last year I had the privilege of coming here and presenting a lot of this man's work about what we had done in Fedora, and you all liked it, and you came to the talk, so we did it again. I want to talk a little bit about what we've learned and what we've done in Fedora here in year 2, but there's some other cool things that have been going on at Microsoft that we wanted to talk about as well because they have intersection and impact with Fedora. So, stop me if you've heard me say these exact words before. Microsoft is not monolithic. There is no single thought. There is no hive mind. And the reason I asked my friends here to make a point of saying what they do at Microsoft was to point out, like, we're on 3 different parts of different organizations, although I think actually in the last reorg we all became one organization, but we're still figuring that out. And so a key thing is Fedora is going to see a lot of participation from Microsoft that, like, you'll be like, oh, these people showed up and did that thing. I'll go ask Bex about that. And I have no idea because it worked. They came in and they participated and they did their thing. And so people are going to show up from different paths with different thoughts and ideas. So take this presentation within that context. I don't know why we keep losing our slides. That said, take this presentation in that context. Probably. It happens. Take this presentation in that context. We're not trying to teach you our org chart, but we're trying to help you understand there's a lot of things going on in the background. Jeremy.
This is me. So one of the things that's happened in the last year, so 2 years ago, we started uploading Fedora Cloud variant images to Azure. And in the last year or so, we've started automated testing of those images. Yes, I can see Adam cheering. However, those tests aren't really reported anywhere external yet, or they're not wired into the wiki workflow that Fedora uses. So over the summer, I do plan to finish that work. So 45 should have automated results for the Azure images in the wiki, so we can look at those during the blocker meetings and final review. So that should hopefully be exciting. And this is great not just for Azure, but for everyone, because a lot of the issues we do hit aren't Azure specific. They're not about Hyper-V. And it's a nice, not second or third, but additional way to test Fedora outputs. As an example, there was a glibc bug that Kevin Fenzi reported, and he thought maybe it was his interesting AR64 laptop, but it turned out that it wasn't. And I was able to go back in our test history and spot the day that it broke, and I had a very small diff of packages, so that made it much easier to go find the root cause. So that's pretty great, and I'm excited about getting that tied into more official results. So that's what we've been up to in the cloud space. I think it's back to you.
We didn't plan for a podium. So Jeremy talked yesterday about signing infrastructure and a lot of the work that he's done there, and I'm not going to repeat it all for you. Please go watch that recording. It was absolutely amazing. What I did want to kind of talk about was some other work that the CLA, our Community Linux Engineering team, does at Microsoft that aligns very closely with Fedora. A big goal around here is to increase the number of contributors. And part of the work of our Community Linux Engineering team is to serve as an onboarding and ambassador style group inside of Microsoft, because we don't want to proxy all of Microsoft's work through that team. We want the upstream, in our side, upstream engineering teams, to be coming directly to Fedora to work as the upstream for the things that we're going to do. We want all of those folks showing up. We don't want them taking shortcuts. We want them doing it the right way, the Fedora way. And the best way is for us to help guide them to the right people in the community to talk to, the right documentation, the right onboarding, and those pieces. I'm going to kind of change tones here. Our colleague Sandeep couldn't be here, so I'm going to try and cover some of his material and try and do it justice. This is some information about Fedora WSL. We began producing official images for Fedora on WSL, Windows Subsystem for Linux, with Fedora 42. This is a graph of active users over that time. You'll notice that it peaks close to about 30,000 monthly active users, which is fantastic. That shows us that people like this, they're using it. It's clearly being used. We're using it some internally. Like, it's a good thing. You'll notice this drop. That's because I don't have Fedora 43 data. We really do believe, and we're waiting on it, that this represents as well a healthy transition from the release of 43 of people actually upgrading their WSL instances. And that's what we want to see. It's what, as a community with a 13-month release cycle, we want to see our users doing. And so we're really glad that that's there. My colleague Sandeep specifically works on something called the Azure Community Gallery. And we launched that in 2024, and it's our answer to how does a project put an image on Azure when they're not like trying to sell it in the Azure marketplace. And so his team launched that in 24, and Fedora was a launch partner with it, and they are super excited about it. This is a chart of usage of Fedora on Azure with some huge asterisks that I want to talk about. This is only direct launches of the Fedora published market or Azure Gallery image. So if someone brought in their own copy, if a third-party publisher published it, they converted some other system, you're not going to see that in this chart. This is literally people who went and clicked on the Fedora published image. The other thing to keep in mind is that this is the image they clicked on. So if those Fedora 40 folks have upgraded to 43, we don't know that. But I really like this chart, and I hope I'm not going too off script, Sandeep, when you review the recording. I like this chart because what it tells me is people have used the Fedora images and are continuing to use the Fedora images based on that 40. But with 43 being second, they're also continuing to launch new ones. We can debate the number in terms of the raw units, like what does it mean, why would you use Fedora in public cloud? Like, those are all great questions, but this shows that the community's output is valued. A couple other things, I'm looking at my notes from Sandeep here. A couple things to talk about as well are that we are continuing to use what we've learned from working with Fedora in Community Gallery to improve the Community Gallery experience. So we're working on some new ways to help publishers like Fedora optimize the way that they're publishing and to communicate better to users who are using the images, and for those users to be able to better tell things like when an image has gone end of life or is going to be deprecated so that they can manage their life cycles better as well. Ruben.
So Bex hit a number of the high points here, but why does Fedora matter to Microsoft across our different teams? As we definitely have heard in the sessions here, right? Fedora is foundational to enterprise Linux. That's definitely true for Microsoft as well. I'll be talking in the next few slides about Azure Linux, which we just sort of formally more fully launched about a month ago at Open Source Summit in North America. And it is based very formally on Fedora as its upstream. Definitely, Fedora gives us upstream signal, via rawhide and future releases as to changes that will be coming to our future versions and changes that we'll be working through how to absorb, integrate, and make work for our customers. We, would like to believe that there's some things we've learned from our work and what we do at Microsoft and with the Azure Cloud that we can bring back, we can contribute in appropriate ways that, we hope to benefit the broader community. And something else Bex hit on a little bit is, what's our intended working model? I can speak also specifically for Azure Linux. We know we need to come here to meet Fedora and the upstream. That's why I'm here. That's why we're here. And we know we need to show up with the contributions and find ways that the things we're doing we can benefit the broader community. So I'll give a couple slides. This will be just a sort of very high level, what is Azure Linux? It was mentioned a couple times, I think yesterday morning. It's what I primarily work on and have been working on for quite a while, even though it was only just more formally announced. So it's a Microsoft maintained Linux distro. It's built for the Azure Cloud primarily. That means for hosting VMs, for Kubernetes clusters, for containers, and also we will be shortly publishing an Azure Linux specific Windows subsystem for Linux WSL image that I use mostly as my daily driver right now for things when I have to be on my Windows laptop. We are formally for 4.0 downstream of Fedora 43. It is rebuilt from the spec, so we're taking sources and input and building the binaries and packages for our distro. What are the main differences? That's definitely a question get asked a bunch. It's intended to be configured, tuned, optimized for our customers, for the Azure Cloud, for our use cases. It's now in public preview, so it's available. It's there. If you're interested in looking at it, the sources for it are all on, or at least whatever sources we have on top of Fedora are present on GitHub. I'm not expecting that you go look there, but if you're interested, it is available and there in the open. Something else I'd like to also introduce, we sort of the other coin, the other half of some of what we do was announced also about a month ago, Azure Container Linux. So that's, if you think of Azure Linux 4.0 as our more traditional RPM-based distro, Azure Container Linux is our more image mode. It's the hardened, immutable, secured container host OS. It's got an interesting derivation. It actually takes its design, its image definition, its SDK from Flatcar, but once we intersect it with our 4.0 releases, it's going to take its packages as inputs to that image build process from Azure Linux downstream from Fedora and kind of putting those two together. The 3.0 version of Azure Container Linux is generally available. Also, the sources for it all on GitHub and available in the Azure Cloud for those who might be interested. We'll get into just a little bit of how do we build it, what's sort of inside, and how do we interface with kind of infra and sources. One of the goals we set out with Azure Linux 4.0 is we want to really highlight where we're deviating from upstream. We want to highlight it, and we want to be declarative about it for ourselves and also for auditability and inspectability. We want to know. We considered, do we do a hard fork? What do we do? We've had various experiences in our past because we have had previous versions of our distro more for internal use within Microsoft. And we realized, of course, with risk of a hard fork is you start making changes. It's hard to know where do the changes come from? How do you rebase? Once you also have sources you can very easily edit, you start making changes that maybe you didn't need to make, but they were really easy to do so. We're really trying to avoid that through construction. So we have a mono repo on GitHub. It's got a set of declarative, we use TOML-based metadata. It includes a sort of a selection of what's the subset of Fedora packages that we include and we build for our distro. and specifically what are the very specific upstream version of those upstream sources and specs that we're taking from. Broadly, we do have a configuration that says take from Fedora 43 as of a certain snapshot, but we also have the capability of saying, no, for this package, we actually want this dist-git commit for this package, and pull that forward so we can pull individual targeted changes. We have specs that we've added, some very obvious ones, Azure Linux release, Azure Linux icons, things like that where it's about branding. Also additional packages that we would like to be in the process of upstreaming and trying to get sponsored for introducing into Fedora, but maybe aren't there yet. We apply per package build overrides, where thankfully there's actually a bunch of useful if-def macros already in the specs to be able to do feature disablement or enablement, or to be able to, let's say, override vendor macros, things like that. Concrete example here, for DNF5, the Red Hat Subscription Manager plugin to it is not relevant for our product, so that's something we can easily just specify a without flag, and the right thing will get sent to RPM build. The other thing that's a little bit more custom that we've done is identifying places where there might not already be those easy toggles, and we do need to make some targeted adjustments to the specs. We wanted to make these as declarative as possible, so instead of going with kind of patches, we ended up going with kind of taking inspiration of more semantic patches where we can say, hey, we want to remove this build require to remove a dependency, or we'd like to replace this argument to cmake_build so that we can disable a feature. Here an example is setting RPM vendor macro in rpm.spec. Now, even as I say that, I realize probably that might be something that could be factored out also as a spec macro in the future. Maybe that's an upstream change that we could try to contribute. What else is in the repo? We do take that metadata as well as the selected upstream specs, and we have an open source tool elsewhere on our GitHub called AZLDev that applies them together and produces the final set of spec and dist-git sources that are going to be sent to standard build tools. So we can send to RPM build, to mock, to Koji to be able to produce. And those are sort of a cache of those that are checked in for transparency and to make sure we've got exactly the same version of those across builds. We've got our base image definitions that are all there across WSL, containers, images. We have a live ISO for installer. Those were a bit more forked. We were heavily inspired by Fedora Kiwi descriptions, which we went and we took as a starting point, and then we customized those for our product, for our use cases, but are using Kiwi and trying to at least stay using the same tech stack. There's additional test metadata. Some of this may include referencing upstream tests that we're onboarding and trying to run within our infrastructure. They also include product or image-specific tests that we're bringing online ourselves, as well as disposition metadata. That's not really a great name for it. Didn't know how else to summarize it. Is we want to basically have accounting for all of the changes that we're making. I mentioned these overlays, these customizations to the specs. Want to have tagging for these of which of these we are really deeming as non-upstreamable branding changes or configuration options. Which of these are things that I sort of see as debt as for our project. These are changes we'd like to bring upstream and see if there's openness to accepting. And I want to have some way to account and see how we're doing with that. I'll go really quick since we're getting a little bit shorter on time. So our infra, we've stood up a deployment of Koji running in the Azure Kubernetes service. So we're able to benefit from a bunch of community stuff we'd seen, containerizing all the different services. We've got that running and integrated with, we use NFS-mounted Azure-hosted blob storage and Azure-hosted Postgres, and we use all the standard Kubernetes stuff, Cert Manager for being able to manage a CA and get the right certs we need for the different services of Koji to interact. We do have a distro-specific build and release service. That's the piece that's more integrating with our own sort of corporate kind of back-end stuff and our more business-driven requirements. It's connected to our GitHub workflows and PR workflows and so forth. Orchestrates Koji builds, manages. We have a look-aside cache that we maintain ourselves that has a fair bit of content mirrored from upstream Fedora, as well as things we're adding or changing versions on. And of course, publishing to all the locations where we have stuff. And that's the super short version of Azure Linux. if people are interested, certainly happy to talk in the hallway or online later where there's interest. And I hope you'll be seeing more of me and some of my colleagues, Matrix and all the usual locations.
Yeah, sorry, we're not recording. This is literally a summary slide. We'd rather have your questions. So, thank you.
Yeah, that's fine. So you were mentioning the life cycle for the Azure Linux, and I have a question about the versioning. So now you are running Azure Linux 4, which is based on Fedora 43. How long are you going to keep this? And if you're going to exceed the life of Fedora 43, are you going to be backporting patches or just right away move to Fedora 44, Fedora 45? And then how this is going to reflect in the versioning of Azure image itself? Like Azure 5, Azure 6, or?
Yeah, that's a great question. I don't have I'm not the right person to have all the answers on some of that, but what I can say is it will outlast, live past the supported life cycle of Fedora 43. We do anticipate, we have a mechanism in place where we can pull updates as, Fedora 43 evolves, or we can move certain packages or sets of packages forward to later versions. Obviously, we know when we do that, we start deviating from kind of coherent set of things that had been tested upstream. So it's a place where we have options, but we will be doing backporting and obviously keeping things, in the current season we're in, CVE patched and appropriate for our customers. There will be down the road, a 5.0, a 6.0, a 7.0, sort of traditional enterprise Linux style. And, at those times we'll be finding the right places to intersect future Fedora releases. Part of it is we're learning, we're in preview right now, so we want to get feedback from our customers around, what they're looking for. Right? Obviously, lots of trade-offs between freshness and stability. I think as we heard about in some previous talks, so trying to find the right fit there, but hopefully, definitely look to share more as we solidify that.
Thank you.
You spoke about people upgrading their WSL images from 42 or 43 and so on. So do you have any kind of prompt in that WSL environment, the CLI environment, that encourages people to upgrade, or do they just figure it out on their own, or just?
Yeah, I can probably answer that, which is I believe no, but that is a really good idea, and we could do that. So.
Well, I mean, I maintain a project I maintain this project called Toolbox, which has like this CLI environment, and yeah, I have a feature request for this for a long time, and I was just doing a market research.
Okay, well, we don't do it, but I like the idea, so maybe we can talk and figure that out and share.
Okay.
Cool.
We have 2 more minutes. Questions? Okay. Thank you.
Thank you all very much. Thank you. Thank you. And now we'll never speak again. No.
We have 2 minutes. Thank you. I have a small announcement, so I'm holding it like. Okay, folks, settle down in, and we have a minute to go. And make sure you take all your belongings after this talk is done. So the AV team is going to kind of rebuild the whole stuff. So, yeah.
All right, let's get started. Hi, everyone. I'm Jean-Baptiste. I work in the CoreOS team at Red Hat, and I contribute to Fedora CoreOS most of my time.
Hello, I'm Joel Capitao. I'm a software engineer working at Red Hat as well, mainly on Fedora CoreOS and Fedora Bootsie as well, with a strong focus on the pipeline, conflux, and so on.
All right, so we're doing the usual yearly What's Up in CoreOS this year. Those have been done by Dusty Mabe the previous years. I'm trying to fill that shoes. Quick refresher on what's Fedora CoreOS. It's a container-focused minimal OS. The goal is treat your machine as a container, so you would like respin a new VM whenever you need to make change, and then think about it as a like immutable entity. It's an image-based system, and yeah, ship with Docker and Podman, so you can choose whatever and run your containers. So new thing this year is not too much. We know support Proxmox as a main platform, and then switch all of the running systems to pull their updates from Quay as OCI images. And a bit before Flock last year, we moved new install to install from Quay, and now we have like, all the nodes pulling from Quay. So those are like the two main user-facing changes that we had this year. And before I go on into like what changed in the backend, I'll just show a few metrics. Because yeah, not so much change, which means FCOS is becoming kind of mature and stable, and then users seems to like that. It's now the most popular server edition of Fedora, I think, given the stats. So those are machines that are more than one week old. Most of them are now Arch64, which is a huge bump from last year. Last year was almost like 50-50. Most of these, we think, because we can't really know, is Podman machine that ships with Podman desktop on Macs. So last week, actually, I filed a ticket with the Podman machine team, so they changed the OS release string. So maybe next year we'll see a different, and then we'll be able to count those. Another interesting trend that we see is people tend to use their FCOS for longer. Those are in red, the 1 week node, and in blue, more than 1 week node. And we see more and more people sticking with the FCOS install. And then a last one is machines that get up for more than 6 months. So that's erased that huge Fedora server, Fedora Cloud blip that we saw in the previous one. And 2/3 of the FCOS machine are there for more than 6 months. So people tend to stick around with CoreOS. So what's changed this year, but on the build side of CoreOS? That was most of the work of the year. We have been doing a lot of Bootsie work. We changed the build system to be container native, so building Fedora CoreOS now happen in a container build. And we also been working on using Bootsie install to file system to build the disk images. And this is now shipping in the rawhide stream of CoreOS. So most of that work have been removing the opinionated bits and building scripts that we have, and then upstreaming those in Bootsy, in Image Builder as much as possible to reduce the specific CoreOS bits that we have. Another last change that shipped like maybe a month ago or so is the OS build root that we use is now Bootsy images instead of COSA. So what that means is that for the rawhide image of FCOS, we used the rawhide, I don't know, MKFS binary, instead of having like one fixed set of utilities that we'd use for all the variants. So like no, each image is built with the matching stream. And what are we working on? And that's the part for Joel.
Yeah, so what are we working on right now? So the next plan. So more Bootsy, surprisingly. So you may ask yourself if we are still doing CoreOS or if we are Bootsy now. But yeah, we are still CoreOS, but we try to be more Bootsy derivative. So yeah, the first bullet point is about generating the disk images. So right now we are using the OS builds pre-compile manifests, which is working really fine, to be honest. We are generating like more than 20 disk images in like 10 minutes, which is pretty fast. But we are not using the Bootsy tooling, and we want to move towards more the Bootsy tooling. So we have to do some stuff about in the image builder on Bootsy. So we have to add some knobs to customize the image builder pipelines for the CoreOS. So we are working on that right now. The second point, it's about the decoupling the ignition part from CoreOS. So there is actually a package, the ignition package in Fedora, so you can install, but you won't have the integration files like the drag-cut config files, the system, the units and presets. So it's living right now in the Fedora CoreOS config main repo, and we want to move out from that repo and to ship all of these files within a sub-package within the main ignition package. So that way, Fedora Bootsy will be able to use Ignition as a first boot installer, as well as all of the other derivatives, like the atomic desktops. And the third point is the testing suite. So right now we are, in the testing suite in CoreOS, there is a lot of tests which are basically basic generic tests that are not CoreOS specifics at all. So there is no point to run them in Fedora CoreOS. So we want to upstream this test in the Fedora Bootsy as well. And the cool part of all of these things is that we will be able to move to Conflux more easily. So yeah, a few words about Conflux. So it's a CI/CD build system that tries to meet the SALSA level 3 requirements. So SALSA, for those who don't know, it's OpenSSF framework which tries to secure the supply chains as much as possible. And in this diagram, it's from the salsa.dev website. You can see the supply chain threads. So from the source at the left of the diagram to the end user. So there is a lot of letters, A to I. And this is all of these, let's say, the vector attacks that can appear in the supply chain. And Salsa tries to address all of these vectors attack. Not all of them, but most of them. And Conflux, it's opinionated implementations of this framework. And so yeah, we are working on that currently. So the cool part with Fedora CoreOS is that we are container native, like Conflux. So it makes a lot of sense for us to use Conflux to modernize our supply chain, to be more secure. So right now, there is some missing part, which is the disk images. So we are building the raw stream, the container image with Conflux, and then we are still testing and releasing with the Jenkins pipeline. But very soon we will be able to do all of this within Conflux. And the end goal of all of this is to be able to cosign verify the Create.io image, and the end user will be able to verify the SBOM and also the provenance attestation. And yeah, that's it. That's basically it for the Conflux.
Don't go and try that command. That doesn't work yet. We need to work with Jeremy to get that working. All right, a few other things that we have in our radar. We want to move to split the container image that we produce using Chunka. That would give us an increased layer count so we can have smaller updates. So moving to OCI is neat for the distribution side of things, but one thing that we had before with the OS3 repo was if your update, it doesn't happen much often, but let's say your update is only one file change, you would only download one file. And then now with OCI, you would only download the layer that contains that file. And then using more layer allow us to decrease the network use for updates. Another thing that would be nice is to have the ability for Ignition to consume butane directly, so that would avoid transpiling butane to Ignition before booting the VM. Because YAML is nicer to write than JSON. That's an opinion. And then longer term IDs, those are like not, I don't know if those happen, but that's kind of a wish list. Maybe have some CSX factory in Fedora so we can distribute extension for FCOS that are supported and built from Fedora content. And also working on supporting people that want to derive FCOS, the Bootsy way. Gersvak talked about that yesterday. And one thing that you can do that today, but then you lose updates and you don't get support. And then it would be nice to find a way to keep providing the update guidance that the FCOS team builds to derive the images. Maybe later, I don't know. Yeah, that's the last slide. Any suggestion, ideas for FCOS, questions?
I'm a happy Fedora Quartz user. We run on it for testing farm, so thank you. I'm just wondering, like, when we have image mode, like, will those two projects like somehow converge together? Because I'm always having this stupid question, like, if we have image mode, right? Like, they are very much getting closer with the Bootsy support. So the only thing is the initialization, maybe with butane and ignition, or is there anything else why people would choose CoreOS? And it seems like they're diverging together, right? So, or converging together, sorry. So can you maybe explain that?
So in a sense, FCOS is a Bootsy distribution with opinions. And also we do a lot of testing and we provide automatic updates with guidance. So we have this update graph where we are able to inject releases that the nodes have to go through. Let's say you have some bootloader migrating code or something. That's the main benefit of FCOS. Like you have a set of updates that you may skip and then some that you may not skip and so on. But in essence, FCOS is kind of just Bootsy with opinions and also ready to consume. You can go and grab a key new image and then boot it without having to build anything. Does that answer the question? Yeah. All right.
So I noticed there was a strong association with the cloud native in the Conflux slide and like for where that's going. How does that relate back to common criteria?
Common criteria meaning?
Yeah, the foundation requirements for building in isolation.
You mean hermetic builds?
Not just the hermetic build, but like, but that is a key factor in common criteria. Yes. Most of the RPMs are built that way, so it's not like it's a scary thing. But I just wondered if that was a consideration in terms of how those builds were created.
I think that's a question for you.
Yes. To be honest, I don't have the answer to that. We are using the Conflux, the base Tecton task, which is chipped within the pipeline. I haven't taken a look really deeply into that security part, but
I would suggest a conversation with Amy Ralph.
okay.
So, how long do you think you'll be you'll be a Bootsy version with opinions, or do you think there'll be a lot more convergence there?
That's a tough one to answer. Depending on the progress and the community appetite for this, and I don't know. We plan to remain FCOS for a while, I guess. But one of the main blocker thing is so when you get your your FCOS image, you can extend it by overlaying some packages, which is something that RPM-RS3 do, and Bootsy doesn't. And then so that's the main thing right now that keeps us sort of like going full Bootsy. And also, like, as long as we want to provide disk images and so on, Bootsy only do containers right now. Fedora Bootsy, I mean. Yeah. Yeah. And yeah, also that means they have to do it. And then right now FCOS does that for you.
Okay,
Thank
I
you.
think we are good. Thank you. Just a reminder, please take all your belongings. I think the AV room is, AV team is going to just change it out.